We study food. Because that is the people's health. We study drugs. Because that is the people's safety. We study cosmetics. Because that is the people's happiness. In order to ensure that your daily life is safe and happy, our love for you is realized through innovative science. Science of love for our people. The Ministry of Food and Drug Safety. The bigger our love, the stricter we become. As an agency that faithfully performs its duties given by the people, everything that our people use, from food and drugs to quasi-drugs and medical devices, to health-functional food, cosmetics, and sanitary products, reflects our thoroughness. In order to keep our food table safe from adulterated foods, germs and viruses, and hazardous chemical substances, we manage the safety of food ingredients according to systematic standards, conduct on-site inspections of manufacturers, and thoroughly manage the customs process for imported food to block harmful elements in the first place. Through the hazardous food sales prevention system, we also respond immediately to safety accidents after distribution. As the country's food and drug safety control tower, we make South Korea a nation that puts people's safety first. The more we care, the more we listen. As we are well aware that our efforts have no meaning without the people's trust, we transparently disclose the safety management information of food and drugs to the public. We also make efforts to improve school meals for our children, take the lead in educating people on proper eating habits, and establish a social safety net based on communication through adverse drug reaction relief system. In addition, we operate the Korea Orphan and Essential Drug Center to swiftly provide crucial medicines to people and prevent drug abuse through systematic management of medical narcotic drugs, in an effort to create a reliable society and a safe nation. Our loving mind is growing into love for the world. We foresee the trends of advanced science and technology and implement food and drug policy on par with the development level of South Korea. With smart approval evaluation and an advanced management system at international levels, we drive the innovative growth of the drug and medical device industries. In addition, we provide technical support for all cycles of the bioindustry, which is at the heart of the Fourth Industrial Revolution. From clinical trials to approval for sale, as well as present international standards through scientific R&D to contribute to technological development for food and drug safety. Our relentless efforts are making South Korea one of the world's 5 powerhouses in the food and drug field. Relief beyond safety. Trust beyond relief. Happiness to the people. Vitality to the industries. We will increase the value of our country. We will prove our love for you by realizing the happiness of the people. Science of love for our people. The Ministry of Food and Drug Safety.
Good morning. Welcome to the second day of 4th MFDS Global Conference on Foodborne Antimicrobial Resistance. I would like to thank all participants, both online and in person, despite your busy schedules. I was the MC yesterday, and I am also the MC today. My name is Jung Ji-yeon from the Livestock Product Safety Policy Division of MFDS. This conference is being held under the theme Global Cooperation and Solidarity to Combat Foodborne AMR. We have a two-day conference yesterday and today. And to give you a brief recap of what we had yesterday, we had an opening ceremony and we had two sessions. The first session was on sharing strategies to tackle AMR in AP countries, where we had 3 presentations. In the second session, we had sharing of global strategies to contain in animal and agricultural sector, where we also had 3 presentations. We had a very meaningful time with presentations and Q&A sessions. Today is the second day of the conference, and we have 2 sessions prepared. We have 8 presentations prepared for you today, and I have a lot of expectations for the constructive discussions that we will have today. Today's conference is also being live streamed on the MFDS YouTube channel, and after the conference, the presentations and materials will be uploaded on our official website. And now we will begin the second day of our conference, starting with the third session. The third session is on the latest technologies to contain AMR. We have 4 presentations prepared for you. And first, I would like to introduce our moderator for the third session. She has been working with us in MFDS for 27 years, working with microbiology division. And she is the head of the microbiology division at the National Institute of Food and Drug Safety Evaluation at MFDS. Her name is Ms. In Sun-ju. Please welcome her with a big round of applause. Hello, my name is Ju In-sun. I'm head of the microbiology division at MFDS. As introduced right now, this session is going to be on latest technologies to contain AMR. It is a time where we are going to share latest technologies that we have. We have presenters from all over the world, from France and also the United States. And we also have a professor from Korea. We have 4 presenters today. So, it's different from yesterday. We want to focus more on the presentations today, so we will have 25-minute presentations each. And for each of the presentations, after the presentation, we will have a short Q&A session for each of them for about 5 minutes. And now I would like to move on to our first presentation. I will introduce our first presenter. She is working in ANSYS in France. She is Dr. Sophie Granier.
Dr. Granier is in charge of the coordinating the scientific expertise at ANSYS, and she has been focusing on AMR and other research projects at ANSYS. And she is also the charge of FAO AMR Reference Center for France. And let's welcome her with the topic of application of WGS for AMR surveillance along the food chain. Please welcome her with a big round of applause.
Good morning, everyone. I would like first to thank the organizer for giving me the opportunity to join you today and talk with you. The question that I was given when we first get in touch was, can you do something about application of whole genome sequencing for AMR surveillance? First I thought, would I give a global presentation, but there are people much better than me to do so. A European perspective, and I think it would be a bit too much. So I'm just going to talk about what I know best, surveillance in my country, France. First of all, I'll start with a disclaimer. What I'm going to present you is only my views. It is not my institute, it is not my government opinion, it's just my opinion that I want to share with you. And before we share my opinion, and we don't know each other, I think I have to introduce myself. So my university background is molecular biology, but I have a PhD in microbiology, and I spend most of my time doing traditional Pasteurian microbiology. I worked a lot I've been very much involved in the EU harmonized AMR surveillance program along the food chain that is regularly published and a gold mine of information. And very recently, I've been asked to join the team of coordination of FAO Reference Center for France. And that's it. Now, I said that it's not the opinion of my agency, but give me a few minutes to present you in 3 slides what ANSES is doing. So ANSES is a French scientific expert appraisal agency. We work in the field of our slogan that we use all the time is investigate, evaluate, and protect. We are supposed to help the decision makers with scientific-based information, and there are so many different expertise in our institute. We work on human health, animal health, plant health. The agency was created in 2010. We are 1,400 employees. Our goal is to product knowledge, and we are deployed all over the territory. It is for production purposes. Where the animals are, that's where the labs are. We are doing a lot of reference activities. Last but not least, because it's in line with our subject today, one of our missions is vigilance and alert. So we've got 5 vigilance schemes, and I see that it's very close from what you are doing here. Toxicovigilance, nutri-vigilance, phytovigilance, veterinary pharmacovigilance, and also preventing occupational health diseases. We have also numerous 3 platforms dealing with human health, plant health, and food chain safety that are gathering public and private efforts and makes the information circulate fast. We have surveillance networks. And one we're going to talk about it later is really focused on antimicrobial resistance, and it's dealing with animal diseases, sick animals. It's called RESAPAT. We have a network on Salmonella, which is quite historical, and also another network on Mycoplasma. And we have observatories that collect data on food quality, table of composition. So that's it. Now you know who I am and who I work for. Let's go back to our question. When talking about surveillance, my first idea was to check what we are talking about. And if you bear with me, I chose to pick the WHO definition of surveillance, which is published in this international health regulation, and I think it will help to focus our talk later. So surveillance means a systematic ongoing collection, collation, and analysis of data for public health purposes, and timely dissemination of the public health information for assessment and public health response as necessary. There is plenty of things in this definition, plenty of requirements that would be important for the rest of the talk. May I introduce you this paper made by some colleagues. The first author is from ANSES also. In this paper, they try during year 2021 to determine in a World Health perspective all the surveillance program that were running in France at that time. And they identified 48 different surveillance programs dealing either with antimicrobial resistance, antimicrobial use, antibiotic residues. They were gathering information about human, animals, and their environment. So far, so good, really a One Health perspective. But if you get into deep, out of the 48 programs, there are 35 programs that are collecting antimicrobial resistant data, and 31 out of them were collecting data related to clinical human samples. So you see that the balance is not really okay. In this paper, there is this nice overview of the 48 systems that they identified. Let me walk you through this figure. So if you look, let's start with the first column in blue. It's going to be the human data. The second column in yellow, going to be animal and food data. And the green column, the last one, would be environmental data. Then let's walk through the lines. The first line is about antimicrobial resistance. The second line is about antibiotic use. And finally, the third line is about antibiotic residues. You see that most of the network, as I said before, are focused on the left-hand corner of this table. So I've been in detail into this paper to try to find whose network are gathering at least a little data by WGS. And what a surprise, there is only 7 that are marked with the red cross that are collecting WGS data. And okay, for most of them, they are what we call in Europe National Reference Center, means that they are in charge of human health only. That's what you have on the top blue corner. Some of them, like the Salmonella and the Listeria, they are mostly WGS based and gather all information over there. But if you look at the IMR data that are NOWELL, that are produced by ANSES, either the National Reference Laboratory IMR on the bottom yellow or the RISAPAT network about sick animals, they gather phenotypic information, and they are doing WGS on a very special occasion on special phenotypes. So we cannot say that the surveillance by WGS is really, really in place for IMR so far in my country. So, what is the situation in Europe and for the food chain? So I've been digging into those big and fantastic reports by IFSA and ECDC, published on a yearly basis with data from food, animals, and humans. And first of all, my first approach was, let's do a search in these documents. So if you look at the document published in 2022, very recently, gathering data from 2019 and 2020, you can see that I found only 31 hits when I search for WGS or whole genome sequencing. That's not a lot out of a 200 pages report. But 2 years after that, if you look at the report published in January, the situation is much better. At least I got 116 match. Why that? And why it's still not, it's still phenotypic data and not a lot of WGS data. Since 2021, we have started to gather information on a voluntary basis, but it's not all the data. I cannot provide the antimicrobial resistance of the Salmonella for France by WGS for the moment. They are only collecting the data for ESBL, AMC, and carbapenemas producing Salmonella and E. coli, which is just a little part of the data set. But at least we are starting to work together. We are starting to collect WGS good quality data. I'm a molecular biologist, and we are talking about this WGS surveillance program for so many years. So my next question was, why does it take so long? It's unbelievable. And I recommend that you might read this paper published in 2017 by UCAST, which is a gold mine if you are dealing with phenotypic studies on antimicrobial resistance. You find everything and a lot of information. So one of those groups really worked on whole genome sequencing for antimicrobial susceptibility testing. And we have to tell immediately that maybe one of the big problems is that WGS is absolutely fantastic to assess, to study, to follow resistance mechanism, but it's definitely not good to predict susceptibility. But predict susceptibility is what our clinicians want. When they want to prescribe to an animal or a human an antibiotics, the only information as they are interested in is, will the treatment be okay? Will it work? Is it susceptible? But us, doing surveillance, epidemiology, we are, in fact, only are interested in resistance. Follow the mechanism, follow the ESBL through the animal herds, or trace some foodborne outbreak, I don't know. But our markers are resistance. And unfortunately, for many, many years, we have gathered phenotypic study because most of the time they were done for clinical purposes. We are just catching the data afterwards, after it has been used as individual test, and make statistics about that. So I guess we have also to tell to our clinician that it won't help, WGS don't help to, for the moment, to predict susceptibility. Maybe it will do better for the moment. Please prove me I'm wrong, but I'm not convinced at all that it will help to predict susceptibility. And we have to admit that, well, traditional Pasteurian microbiology is considered to be slow. WGS is much more slow. And, it's not fast. And also, I think one of the limitations is that who's going to pay? Because when we were collecting clinical data, they were paid by the system, they were paid by the farmer. But this surveillance, not linked to any clinical event, should be paid by someone. Also, and I've been into that group, we told to our stakeholders that WGS was the gold standard, that it was easy, fantastic, reliable. No. And since we are using it, we must say that it's not. Not really. We need to work on it. And very recently, in September, this paper was published by the team of René Hendriksen. I think it was here last year for the third edition of this conference. So in this article, they did a proficiency test for 2 years in a row. And they have national reference laboratory from different European countries participating, I think it was 16 the first year and 19 the first year. My team was participating to this trial. And we discovered that the results are not that good. There is a little work to standardize and to do, again, some laboratories were really outliers. And they conclude this article that by saying a nice sentence about challenging of dealing with the contamination. Okay. So my image, the image I gave you is quite bad. I want to be optimistic. There are plenty of things published, new information, new progress. On the top left corner, I want to show you that there is an ISO-certified workflow to analyze the data and get to the detection of the mechanism, and it's quite reliable. In the meanwhile, ISO set a group, it was a year ago, to work on AMR testing, determine what's going to be the future, try to be a bit in advance and prioritize. Would it be Malditoff? Would it be WGS? Would it be metagenomics? Would it be? Everything was open to discussion. And the top priority is WGS method. And the top priority inside the WGS method is to certify the way we're going to identify the gene, identify the mechanism. So the project is on its way. Bear with us. I'm happy to be part of this group. And I think it's a long way, but there is a strong will of collaborating and writing something clean to have something harmonized. Go back to René's team paper that I shown on the slide before, the bad point of the study. But you got to be optimistic. Within 1 year, some labs really improve, which means if we work together, if we standardize our method, and if we understand what are the problems, we make progress, so it can be fast. So, standardization of all the steps of the use of WGS, it's on its way. Don't forget, for the moment, please, with WGS, focus on resistance and not on susceptibility. It would be dangerous. Costs are going down. Quality of the data are going up. Our experience in the lab are going up. So there is everything to say now to my question. We are not there yet, but very soon we should be. I want to thank my colleague from ANSES for constant discussion, and again, the organizing committee to have invited me here, and I'm ready for your questions.
Thank you so much, Dr. Granier. You have introduced us into the agency of yours and surveillance importance for human, animals, as well as environment. And whole genome sequencing is one of the frequently used technology for AMR surveillance, and thank you for your introduction. I would like to open the floor for any comments or questions about the presentation now. For your reference, any person who's watching us online can leave comments on the chat box for Q&A.
Thank you very much, Sophie, for your interesting presentation. So in the future, we have to test both AST and whole genome sequencing together, or whole genome sequencing can be replaced, AST can be replaced by whole genome sequencing. What is your opinion on that?
It's dependable. If we want to survey, follow the mechanism, follow the hazard, WGS, it's much more interesting. Really, really keep the susceptibility test for clinical purposes. And I think one of our mistakes, and one of the reasons some teams are very late is that because we mix objectives, which are totally different. So set a system for the objectives that you need to achieve.
Thank you, Sophie. You mentioned the work by René, and our Danish colleagues, they love this whole genome sequencing, and they say it's all easy, and you make it and you put it in the cloud, and it's out there. No? Then I worked as a clinician for 5 years, and I always thought that we could have something like when we go to Amazon or Booking.com, and you say something like 70% of the people that bought that book also like this book. No? And I always keep thinking that on whole genome sequencing, if you're a clinician and you can upload that easily, like our Danish colleagues say, the sequence to the cloud, you should also have a result like 70% of the cases of this sequence should be treated with ampicillin, with 80% of results of success. Do you think this is scientific fiction, or we'll get to that point?
No, it's empirical clinical data as it used to be. It's much more top of the modern data, but in a way, 100 years ago, your doctor or your veterinarian was doing things like that because they couldn't get the test. So from the test and from the surveillance, we can determine sometimes hotspots, some animal husbandry, some area of the world where there is a high percentage of this mechanism, so there is a high probability that this treatment don't work. But as a veterinarian, if you ask your client to pay for a sample, they don't want the statistics. They want to have an accurate result with this sample. And for that, I'm not sure that WGS is the tool. And again, I love this tool. I'm a molecular biologist, but we have to admit that sometimes it is not the answer.
또 혹시
Any other questions or comments from the floor? Let us now move to our second presentation. Thank you so much, Dr. Grenier.
Yes, and now we will move on to the second presentation. The second presentation will be given by Professor Bang Le-ung at Aju University. He is currently serving in the medical information department, and he is a healthcare professional. He is also doing data analysis with 60 institutions, and he is contributing a great deal in effective patient treatment. And he has also established a research-free zone where people can use common data for international research. Also, working with healthcare and technology together, he is leading the medical information sector in the world. Professor Park today will be presenting on AI algorithm to predict personalized empirical antibiotic selection. Please welcome him with a big round of applause.
Morning. It's my honor to be invited here to share my study with you. Today I would like to introduce about my study entitled "AI Algorithm to Predict Personalized Empirical Antibiotic Selection." I come from the hospital side. Briefly, I graduated medical school and 1 year of internship and had 4 years of residence in the surgical pathology. So I got the board certification at 2000. It's 24 years ago. And at that, I changed my career into the medical informatics. So I never seen the microscope for the past 24 years. So I forgot how to handle the microscope. Just I'm focusing on the medical informatics, how to handle the medical data in the hospital. So, yeah. So you are expert, so we all know that antimicrobial resistance is increasing worldwide and known to one of the top dangers to humanity. Here, there are multiple causes of antimicrobial resistance as follows. However, in this presentation, I would like focusing on the inappropriate antimicrobial prescription, especially how to improve empirical antibiotics prescription in the hospital. Okay. When treating systemic infection, physicians first need to identify the microorganism causing the infection and check its antibiotic susceptibility. However, in case of severe systemic infection, we can't wait for test results before starting treatment. So after taking samples from the patient, patients usually begin empirical antibiotic treatment based on the patient's overall condition, past history of infection, and the hospital's current antibiotic resistance data, or so-called local antibiogram. If the chosen antibiotics are inappropriate, it can lead to increased AMR and worse outcome for the patient. This is an example of antimicrobiogram. It provides recent susceptibility status of the microorganism to different antibiotics in the hospital. It is very important in the hospital for the empirical the prescription, antibiotic prescription. However, it has several limitations. Sometimes it is not available to the physician on bedside, and also it is outdated. It updated usually biannually. That means some data can be very past one, so that it cannot reflect the current situation of the hospital. And also, it do not provide antibiotic resistance profile. That means the distribution of the resistance in the hospital. And sometimes it is limited by MDRO or prevalence. So let's suppose this is what we try to improve. It would be great if AI algorithm could. I'm sorry. Okay, I'm sorry. It would be great if AI algorithms could predict the best antibiotic for a patient based on the patient past and current condition, plus daily updated local antibiogram, along with the likelihood of the resistance, even without waiting for the culture result. If the prediction is accurate, we could expect better outcome, and we can reduce the risk of AMR in the hospital. Of course, there are many prior researches on these topics. However, they are limited by low performance or non-specificity. So currently, the choice of empirical antibiotics relies on clinicians' expertise and limited available data. Thus, we aim to develop AI models to present numeric antibiotic resistance risk score at the time of initial empirical antibiotic selection on admission to support CDSS. This study focusing on the hospital-acquired urinary tract infection. So for this purpose, we use the EHR, electronic health record data in our hospital, but it is already converted into the OMAP-CDM. It's a kind of a de facto standard. Is there someone who ever heard about the OMAP-CDM or RDC? No. Yeah, I'll explain in the later part of my presentation. So OMAP-CDM is a kind of a de facto standard used in the medical field. Our database is already converted into the OMAP-CDM, and the study population was focused on the nosocomial, suspected nosocomial infection for the urinary tract infection for adults. So we used this kind of enroll and exclusion criteria. In our databases, there were about 780,000 records of urine culture result from the 233 patients. Also, for the antibiotic susceptibility test result, there were about 9 million tests from 132,000 patients, and there were about 135 types of susceptibility test results in our hospital OMAP-CDM databases. Oh, I'm sorry. Yeah, I have to handle this notebook and that, I'm sorry. So the outcome was to predict insusceptibility. And the predictor or independent variable for the AI model, we used the candidate predictors from the demographics of the patient, condition. Condition means the diagnosis, and the drug, the measurement, and procedure, visit, and also the local antibiogram from the hospital. And to select, there are too many variables in the hospital. We tried to select the important variables from all of the available variables. So we used the lasso shrinkage for full AI model, and also we used the lasso shrinkage plus clinical knowledge for the parsimonious model. Or parsimonious model means the very simple version of a model. So we use the lasso logistic regression and XGBoost random forest and the stacked ensemble algorithm to make the AI model. And for the model calibration, we use this the kind of measures. So for the model development, we use the patient characteristics, including the clinical observations, disease severity, history of MDRO infection, and previous antibiotic exposure, plus the hospital data. That means the local antibiogram. And we try to make an AI algorithm like the right side. So if the physician enters the patient current and past history or current status, then the AI make the probability of resistance of each antibiotics for the patient, like the right side of the slide. The right side of the slide also it doesn't work. The shows the distribution of the insusceptibility of that antibiotics in the hospital. The red bar, the right side, the red bar means the current status of the patient. And this is the baseline characteristics of the patient. For the ampicillin, about 5,000 patients were enrolled. Ampicillin and sulbactam, about 5,000 patients enrolled, and all the clinical characteristics of the patients are presented in here. And as a result, we use the age group and sex for demographics. And for the condition, past condition, we use the hypertension, diabetes, hyperlipidemia, etc. And for the past and current condition, we use the pneumonia, sepsis, UTI, cystitis, nephritis. And also we use the local antibiogram. And also we use the history of the IV antibiotics, PO antibiotics like that. And also we use the prior MDRO, including VRE, MRSC, CRE, ESLB. And also we included the procedure for the predictor. And also we use the patient past inpatient visit or ICU visit history. So this is the result for the ampicillin. The performance AUROC was about 0.7, and also for other antibiotics, the performance are very similar. So we use the 4 kinds of AI algorithm, including the lasso logistic regression, XGBoost, random forest. All of the performance were very similar. And for the explainability of the AI algorithm, you use the sharp value. The sharpness can quantify the contribution of variables to the models. So for the ciprofloxacin, we can see that the age and the antibiogram is very important to determine the probability of insusceptibility. But for the piperacillin and tazobactam, we can see although age and antibiograms are very important, for the prediction. However, as you see, the ESRD, urinary infection, IV, anti-pseudomonas, continuous IV injection, like other factors, the patient current condition is also important for certain antibiotics. So in some antibiotics, the antibiogram itself is very important, but for others, the current or past conditions are important. So we can see what it's important for the prediction of the model. Because it is very hard to calculate all of the input, all of the variables by the clinicians on site, so we developed an application that works on the website. It is developed by the Shiny. So the patients just easily can click the proper condition of the patient. And if you want, you can explore the site here, the right side. This is the address for the app. So this is the result. For this this is the for the patient. I think the PPT, I forgot the acronym of the piperazine and tazobactam. I think it's the best choice for the patient before we know the culture result. And other, what was the ciprofloxacin? I think ciprofloxacin is the very poor drug, must be very poor choice for the patient because it has about 55% of the susceptibility. And in the right lower side of the graph, we can see the distribution of the susceptibility in the hospital. And the patient is around the middle of the distribution. And also in the right lower side, we can see the susceptibility changes over time. Also we can see the seasonal variation in the hospital. So in some seasons it's very low, in some seasons very high. So, but it is increasing continuously. This is another example. Here, the patient is very lucky because he has more options to choose for the empiric antibiotics. So with these applications, the physician can choose the correct antibiotics can be good for the patient progresses and reduce the inappropriate AMR. Okay, this result was published in the International Journal Antimicrobial Agent last year. So if you have any interest, I think you can refer the paper. In the first part, I explained about the MFDS. It's a kind of the standard EHR standard for the analysis. It is led by the Odyssey, or Observation Health Data Science and Informatics. That was started as OMAP in 2007, and then it changed to Odyssey in 2014. Odyssey has been established as a multi-stakeholder interdisciplinary collaborative to create open source solution for large-scale analytics using the MFDS. So now it is 2 years old data, but now there are more than now it's about 4,000 collaborators from the 80 countries, and also there are about 500 data sources from 41 countries. It covers about 928 million unique patient records. That covers about 12% of the global population. So in Korea, starting in 2014, I was the first in Asia to convert our hospital's EMR data into the MFDS. Since then, the number of participating hospitals has steadily increased from 2018, with government support, 2 large research projects has been carried out over a 5-year period. The goal of this project is to convert the hospital EHR data into the MFDS, at least 61 hospitals into MFDS, and connect them through a network for share use. This is a kind of distributed research network. Here, the data cannot come out from the hospital. As all the hospital data are standardized using the MFDS, if someone wants to analyze the hospital data, then he can make an analytic code using the R or SQL. Then he sends that analytic code into each hospital. Then the hospital run that analytic code, and they can get the analytic result. Then they send back that analytic code into the center. So even though we do not have data, we can analyze all the participating hospitals, the summary result. Also, we can make an AI algorithm using the federated learning. It is a time limit, I will not explain well, but using the federated learning, also we can make AI algorithm that works using all of the participating hospitals. So as a result, now 75 hospitals in Korea, including over 80% of tertiary teaching hospitals, are now part of OMAP-CDM in Korea. This means that all structural data from the EMR of the participating hospital have been converted to OMAP-CDM, and we can freely access the 75 hospitals' data. Also, but the problem is the data governance. Some hospitals cannot provide their data to other hospitals. Sometimes it is very limited. So we made a research for the freedom, so-called RFG. That means within the RFG, it permits unlimited reciprocal data access with single IRB between the RFG. So now we have 34 hospitals in research for the free zone. So in any researcher or anyone in the hospital can access this data, but they cannot see the raw data. Just they can send the analytic code to the hospital and only get the statistical data, or they use the federated learning to make an AI algorithm that works fit to every hospital data. And now more than 30 hospitals OMAP-CDM data updated daily or weekly or monthly. That means we can access the very recent hospital data with using these systems. Since Korea already has an established OMAP-CDM network, so I'd like briefly introduce an existing project that used this OMAP-CDM network to build an infectious disease surveillance system. This is a working scenario. First, data, the upper side, the data on infectious disease from participant hospitals EMR is automatically converted into OMAP-CDM format daily. And however, the data stay within the hospital, but if someone with access want to analyze it, they send the query to each hospital. Then only the analyzed results are gathered centrally for use. With this system, we can learn different kind of monitoring and syndromic surveillance systems without needing manual data entry from the hospitals. And the lower side, in case of epidemics or pandemics, patient clinical data that is standardized through OMAP-CDM can be centrally collected either through legal means or with patient consent. Authorized personnel can then access this centralized data and view individual clinical information gathered and integrated from multiple hospitals. So this is a 3-year project, and this is the last year. So we named PAROS, Integrated Infectious Disease Clinical Information Management System, using real-time OMAP-CDM. So now the 4 largest hospitals in Korea joined in this project. So the data on the infectious disease are converted into the OMAP-CDM daily. Then it just exists in their hospital. Only the analytic code go into each hospital, and we get the result. What we want for. Can be used for the syndromic surveillance or some kind of statistics. But in the emergency situation, by law, patient consent, the patient data itself can be gathered into the server, in the cloud server, and the authorized person can access it. This is the one example, we use the MFDS network for the infectious disease surveillance. Also, another topic led by the MFDS, in Korea, MFDS, it is about 20 hospitals will be joined to that project. That project aims to the surveillance of the medical device safety. So each hospital's the use of the data on the medical devices are converted daily into the MFDS. Then in the same way, the MFDS use that data to monitoring the safety of the medical devices. So also another project in Korea also in the emergency department, about more than 20 hospitals joined in that project named Aegis. They are also the emergency department medical data converted to MFDS daily, and they use for that data to develop the AI algorithm using the emergency department to monitoring some kind of the event in the emergency department. Like that, in Korea, the 75 hospitals already have the MFDS platform, so we can reuse it various purposes. So this is my suggestion. How can we use this MFDS network for AMR network? As I mentioned earlier, Korea already has a well-established MFDS network covering 75 largest hospitals. So if we could convert each hospital's local antibiogram and related data into MFDS on daily basis, I think we could potentially build a system supplement existing national AMR monitoring system with a minimal cost and no manual data entry. I think this is the final slide. So we are aiming to address the issue of antimicrobial resistant by developed on AI clinical prediction models with a focus on standardization and explainability. However, key data like travel history, antibiotic resistance rate, transfer record, and past data from other hospitals can be harder to access. To tackle this, we need a national clinical data exchange platform for AMR. And the RDC MFDS framework could be promising standard for sharing AMR data. By utilizing the existing MFDS network in Korea, we could supplement existing national AMR monitoring network. Thank you for your attention.
Thank you, Professor Park. Professor Park introduced to us the a prediction model using AI, which predicts the antibiotics that are adequate for individual patients, which can induce appropriate use of antibiotics and also which can also lead to reduction of AMR. If you have any questions on this, please raise your hand. Hello, thank you for the presentation. I want to know about OMUP-CDM data. I think the OMUP-CDM data has a lot of timely and good accuracy data. And this data and the foodborne AMR data, so food-related AMR data. For example, in the MFDS, we have food-related AMR data, or also the AMR data from animals or agriculture. So can we have these data working together so that we can make the judgment of whether the antimicrobial resistance in patients are coming from food or agriculture or animals or other things? I know that you have the whole genome data and the data in humans. I think you are using OMUP-CDM here, so can we use this together?
So I cannot explain with English. 그래서 굉장히 중요한.
Yes, I think that's a very important point that we need to keep in mind. So basically, the data is very different. So it is very difficult to directly use them together, but what we can take into consideration is lately we have a multimodal foundation. So ChatGPT 4.0 is a multimodal program, which means we are using many different types of foundations and domains and converging that into one. So we use text data, image data, and a lot of different data and converge that into a more effective program. So from my perspective, these two are very different domains and is not connected through one personnel. So if we can connect this, I think we need to use a multimodal foundation system. And I think for the seasonality and also for the regions, some of the data are already integrated. So the 75 hospitals are distributed nationwide, and also the food and foodborne AMR is also, the data is differentiated by regions. So maybe we can connect it by region. I think we can do that partially. Thank you. I have another question. I will be using Korean as well. Thank you very much for the presentation. I have two questions. So I don't really know that much about the Medical Act, but you talked about two scenarios of OMAP CDM. There is the epidemic situation and the non-epidemic situation. In the epidemic situation, you're allowed to see more patient information. So what is the difference in background for these two? And the second question is regarding private information. And there's a lot of issues regarding leakage of private information. So how are you dealing with that? Yes, that is also a very important point. So first, to answer the second question, basically the data is EHR data coming into the OMAP CDM, and we cannot see the individuals for the data. So it is anonymous, not anonymized.
Identify data, and then the researchers only can access, they cannot access data directly. They only can send the analytic code into the hospital. So they cannot access the data, just they can get the summarized statistical result. So it is, so in this system is a kind of the anonymized research network. So basically, it do not have any problem on the data privacy. The second one, the first question, the first question is about the centralizing the patient data into one and see someone that integrated data. It cannot. It is prohibited by law. But so that system work only by law in a pandemic situation. Some laws can permit that collect the patient data, and the second one is the patient consent, that the patient wants to share the data into the authorized person. So by this kind of mechanism, the data can be freely used. Okay.
Thank you for the presentation. I want to ask you why UTI was selected as the disease among the various diseases that we have out there. And regarding the patient characteristics and local antibiogram, the AI modeling results shows the empirical, I think this is a modeling to select empirical antibiotics, and in the actual patient urine culture, I want to see what results and the prediction regarding the results.
Infection is very common in the hospital. So for this kind of the AI study, we need lots of data. So we have the data, the plenty amount of data is very important. So that's the reason why I choose a unity infection for this study. And the actual performance, it can be measured only by the prospective study. But this study was performed the retrospective study, the retrospective observational study. So I think it's a very good point. So to evaluate the real performance of this algorithm, we need a prospective the study. And another thing that we are trying to in the next step is using the federated learning. And the federated learning is a kind of the making AI algorithm without the sharing. Just we make an AI model, then send that AI model to each hospital, and then run that AI model in the hospital's data. Then we can make a local optima model in each hospital. Then we get the topology and the weight of the model. Then get back into the center, and we summarize it, and we send it to each hospital again, and we reiterate it 100 times. Then finally, the AI algorithm, the made algorithm can work each hospital very well. So it's a kind of the virtue of the federated learning. So we developed already that platform. It implemented the platform. So we will, in the future, we will use the federated learning algorithm to make an AI algorithm works better and fit each hospital. So the next step.
발표 잘 들었습니다, 교수님. 저
Thank you for the presentation. I do have a similar point to raise. So if we use this AI model, after you use this AI model, did you get some feedback from the physicians who use them? And how effective do you think the actual results of using this AI model will be by physicians? Do you have that kind of result? And the physicians need to select the AI model and select the antibiotics with this AI model. And do you have any ways to raise the accuracy of the model? Thank you very much for the good question. So most of the AI algorithms are based on observations. They are retrospective studies. So if we want to have good results, really effective results, then we need to have more research and more tests. And we need to have funding for that. And when we make a model, the model is not always effective immediately. We need to train it. We need to have continuous training for with the recent data. So, for example, when we make a model at Hospital A, then we cannot directly apply this to Hospital B. So we need to have these fine-tuning processes in order to apply these actually to hospitals. So we need to have a continuous process of making the model, training the models, and we need to have a seamless process of that. We need to have a platform, and then we need to continuously train the data and develop it and improve it. And in order to make this fit to each hospitals, we need federated learning. So overall, the most important thing is to make this platform. We're not just using one algorithm, but we need the federated learning system to standardize some form and then fine-tune the details in there. So we need to make a system where we can have customized models continuously. Okay, so we are running out of time. So if you have any other questions, I think you can individually have some discussions. Thank you very much.
Moving on to our third presentation, I would like to invite Ms. Heather Tate, who is in charge of NARM's program as a science leader at FDA. Dr. Tate has been studying and researching AMR surveillance system for 15 years. And she has been in charge of Transatlantic Task Force as well as Codex Ad Hoc. She has been in charge of National Task Force as well as committee groups. On behalf of the US government, and the topic of her talk is NARM's use of technologies for AMR surveillance and monitoring food. And she has been conducting various antimicrobial related research. Once again, the title of her talk is NARM's use of technology for AMR surveillance and monitoring in food. Please give her a big round of applause.
First, I'd like to thank the organizers for inviting me to talk about NARMs and how we're using these various technologies that I will be speaking on. I also want to say a disclaimer that these are my views and not necessarily the views of FDA, so just be mindful of that. All right, and so in the presentation, I'm going to give a brief overview of NARMs and how we're One Health monitoring. I'll talk about our use of whole genome sequencing, visualization tools that we've created, as well as the use of long-read sequencing, metagenomics, and artificial intelligence/machine learning. So NARMS is and has been for most of the existence of the program a tri-agency program. And so, we are a collaboration among 3 major government agencies. CDC is gathering data from sick persons, and that's coming from all 50 state labs. FDA, we are working with 24 state public health and university labs to go to their local grocery stores and collect retail salmon, shrimp, tilapia, chicken, turkey, pork, and beef, and they are isolating antimicrobial resistant enteric bacteria from those retail packages. And then USDA, or the US Department of Agriculture, they are in the majority of processing plants in the US, and they are collecting animal ceca as well as product testing from broilers, turkey, swine, cattle, and other animals as necessary for certain pilot studies that we might do. And that actually does not include shrimp. I'm just noticing that now shrimp, fish, and fish are not part of USDA's purview except for catfish. But all of these data are integrated into annual reports that we publish online. And then, we're expanding into the One Health paradigm. And so by doing that, we're also looking at animal health. And so we have newer collaborations with programs at FDA and the USDA that are collecting isolates from sick animals, both food animals and companion animals. And those isolates are coming from veterinary diagnostic labs across the US and even in Canada. And so most recently, we've included some of that data into our reporting tools. The other aspect of us reaching into One Health is that we have a pilot study looking at AMR in water. And so we are working with the U.S. Environmental Protection Agency. We're leveraging 2 of their existing surveillance programs where they're looking at, one is looking at national rivers and streams across the U.S. And so we've co-opted that, and we are looking at AMR bacteria and as well as antimicrobial resistant genes just in those national rivers and streams. And then there's also another pilot study that's on a smaller scale. It's in one watershed, but it's a very intensive pilot study in that we're collecting a lot of metadata from that study so that we can figure out what the drivers are for resistance in the water environment. And I know that a lot of programs that are reaching into the environment now for AMR monitoring. They're looking at wastewater. We're starting with surface water because surface water receives human, agriculture, and wildlife input, and they're also the source, water sources for humans, agriculture, and wildlife. And so the methods that NARMS uses involve culture-based methodology. And so, we're isolating our bacteria from a sample, and we're doing whole genome sequencing, and we're doing broth microdilution antimicrobial susceptibility testing. I should say that whole genome sequencing, we were actually able to jump onto that fairly quickly, and the reason is because we leveraged existing programs that the US has, such as PulseNet, which is at CDC, and Genome Tracker, which is at FDA, which has for many years used molecular techniques to identify and track outbreaks, foodborne outbreaks. And as they started to use whole genome sequencing, we were able to leverage those systems and use them for NARMS retail meat surveillance. And so really what NARMS had to do then was try to figure out how the whole genome sequencing data relates to the susceptibility testing data that we had been generating for years. And so we put out publications almost 10 years ago now, where we looked at the resistant genotypes and phenotypes across all the bacteria that we're testing in NARMS, which includes E. coli, Salmonella, Campylobacter, and Enterococcus. And we found that there was a really high correlation between the phenotype and the genotype for all of our NARMS organisms. Although it did somewhat vary depending on the drug that you looked at. And so, for streptomycin is an example of that, where we actually recommended that the breakpoint that we had generated, we called it a NARMS breakpoint. The breakpoint that we were using for our surveillance, we shifted it lower. And actually it's an ECOF because this is not based on PKPD data. So we shifted it lower because when we compared the phenotype and genotype, we got a better sensitivity and specificity when we lowered the breakpoint to 32 micrograms per mil. So the implementation of whole genome sequencing in our retail meat surveillance program has been stepwise. Since 2015, we have sequenced all of our Salmonella and Campylobacter, and since 2019, we've sequenced all of our E. coli. Prior to that, we were sequencing just multi-drug resistant E. coli, or sometimes every other E. coli. It varied by year. And then we're also sequencing select Enterococcus. And again, leveraging that partnership that we had with Genome Tracker Labs, we were able to send our historical isolates that we collected since the inception of our program, which began, the retail meat sampling began in 2002. So we were able to send all of those historical isolates to Genome Tracker Labs, and they did the sequencing. So we have all of our collection from 2002 to now 2024 has been sequenced. In 2019, we transitioned our sequencing responsibilities to the NARMS retail meat sites. And so now we have WGS data that's generated from the sites that is being directly submitted to the National Center for Biotechnology Information, or NCBI. And they're submitted under NARMS bio projects. And these data are shared with the public in real time. And because we're using whole genome sequencing, there's a greater sensitivity now in our surveillance for detection of emerging resistance and also more rapid detection of outbreaks. Beginning with 2023 retail meat data, we are sequencing all the Salmonella, Campylobacter, and E. coli isolates, but we're only conducting phenotypic susceptibility testing on 20% of those isolates. So that just speaks to our confidence in the whole genome sequencing data. Again, this is for surveillance purposes. I know we talked about, for clinical diagnostics, it might not be that reliable right now, but for surveillance, we have a lot of confidence in this so that we only have to now do susceptibility testing on 20%. And the reason that we're continuing to do it on 20% is because we want to, over time, see if the correlations that I talked about earlier, if those are stable. And then also, with whole genome sequencing, the fallacy of that is that you only know what you know. So if a resistance gene has not been annotated or previously identified, then when we run our sequences against that database, it's not going to be identified in our sequences. So if we're continuing to do susceptibility testing, we might be able to uncover new mechanisms that might be emerging. So again, the states are submitting directly to NCBI their pathogen detection pipeline. Is what NCBI uses. So basically, the NCBI is clustering these genome assemblies, and then they're inferring trees from those clusters. But at the same time, they're also annotating the sequence data using tools like SeqZero to uncover the Salmonella serovar, if it's Salmonella, or AMR Finder Plus, which identifies the antimicrobial resistance gene. The AMR Finder Plus also identifies virulence genes and stress genes. And so on the right, what you see is basically the output of the pathogen detection pipeline. And so we take all of that data, including user input metadata, and we put it into a visual analytics software platform called Tableau, which is a business analytics platform, but we're using it for our whole genome, to display our whole genome sequencing data. And the tools I'll talk about in the next couple slides are NARMS Now Integrated Data and Resistome Tracker. So NARMS Now Integrated Data integrates resistance trends across all of the bacteria that we are analyzing in NARMS and across all of the sources that we are analyzing in NARMS. And the really nice thing about this tool is that it seamlessly integrates both the susceptibility testing and the whole genome sequencing results. So unfortunately, it's not showing up very clearly here, but if you were go online and look at the line graphs, you would see that there are dash lines on the line graphs and solid lines. The dash lines indicate phenotypes that are predicted from the whole genome sequencing data alone. And then the solid lines indicate phenotypes that have been confirmed by antimicrobial susceptibility testing. And it's really neat to see how it really looks like a continuous line. That's just how well whole genome sequencing predicts susceptibility testing. And then if you were to scroll over any data point, you'd get that what you see at the histogram that you see at the bottom in red and orange, which is basically a display of the proportions of different resistance genes that make up that resistance phenotype in the graph. So as of August 2024, the last year with finalized susceptibility testing data from all three agencies is 2021. So solid lines to 2021, but predicted phenotypes are current through 2024, so dashed lines between 2021 and 2024. Resistome Tracker is another tool that's on our website, and so Resistome Tracker, the main difference between this and the previous one, NARMS Now Integrated Data, is that this one looks at all of the data that are at NCBI, not just NARMS data. And so that allows us to look at more bugs or more organisms, as well as other countries. And so you're able to look at and other sources. And so you're able to look at resistance genes and see maybe what country they might have originated in and where they are spreading to, what source it might have originated in that's not a human or food animal source. And again, this is only possible through freely shared genomic data. So another plug for, countries sharing their data in these sort of global data storage programs, so that data can be compared across country and analyzed across countries. And so the use of whole genome sequencing has really been a game changer when it comes to identifying and characterizing emergent resistant strains. So this was really evident to us in 2014 when NARMS identified a BLA CTXM gene that we had never seen in the US before. In fact, we rarely, before then, we rarely saw CTXM genes in the US, but we saw this particular CTXM65 allele in retail chicken, chicken Sika, and in humans. And it became just a big phenomenon in the US. We published papers since showing that this particular strain of, I never mentioned what organism is in. So this resistant allele is in a multi-drug resistant Salmonella infantis. So we've seen this particular strain of infantis spread across the US, and not just chicken now, it's in turkey. And as you saw yesterday by the presentation by Dr. Lim, it's in Korea too. It's in other places around the globe. And so we have continued to work on this particular strain, looking at its clonal distribution. And Song Lee, who's a scientist at FDA, she published a paper earlier this year which confirmed conclusions from other researchers that this MDR Salmonella infantis BLA CTXM65 positive strain originated in South America. And furthermore, in her paper, she also concluded that it was probably introduced into the US at multiple locations and at multiple times. She also made a really interesting observation that over time, the strains that are in the US have been losing their resistance genes, but the strains that are in South and Central America, they gained resistance genes initially, and then they've kind of maintained the number of resistance genes that they had. And so looking more closely at the plasmid that is conferring the resistance phenotype to these strains, also called the PESI plasmid, that plasmid has two regions in it with AMR genes. And so when you look at region 2, you see that the resistance genes in region 2 are falling off that plasmid faster than the resistance genes in region 1, which we think has to do with the location of these genes in relation to the replicon, the INC-FIB replicon, which is what this plasmid is, the INC-FIB plasmid. But overall, we think that the reason that these genes are dropping off of this plasmid in the US is because in the US, the poultry industry has shifted their operations to no antibiotics ever. So there is no antibiotic selection pressure to maintain these resistance genes on this plasmid. Now that is changing a little bit more recently. You hear that the poultry industry is again now using antibiotics again, but these are not medically important antibiotics. They're things like ionophores, which are not used in human medicine. And she also determined that the PESI plasmid had moved from Salmonella infantis into Seftonburg, Salmonella Seftonburg, and she was able to basically pinpoint the time and location that happened, and again, using whole genome sequencing. So I said I would talk about long read sequencing. So most of what I've talked about up till this point has involved short read sequencing, which again helps us reveal AMR patterns and assist with outbreak investigations. Long read sequencing allows us to close the genomes and start to look more intently at structural variants of circular chromosomes and plasmids. And so long read sequencing brings us a higher level of resolution for our surveillance efforts. Whereas before we were looking at the spread of bacteria between sources, or AMR bacteria between sources, with long read sequencing and closing those plasmids, we're able to track the spread of AMR determinants between bacteria, which adds another level of complexity, but a lot more information to our surveillance efforts. Also, by closing the plasmid, we're able to characterize these plasmids and also look at co-selection factors that might be on those plasmids, including the heavy metal resistance genes, biocide resistance genes, et cetera. There's one researcher at FDA, Dr. Lucas Harrison, who has been using long read sequencing to develop a tool called low-seq, which can classify plasmids using not only the sequence of the plasmid, but also the position of these various loci specific to plasmid type. And so it comes up with this alphanumeric identifier, which is always useful to someone like me who's an epidemiologist. We can start to see whether this plasmid type is, what source it's been found in, what AMR genes it's been related to, and how we're seeing it sort of be distributed nationally and internationally. And when he used low-seq to classify INC-C type plasmids, low-seq provides a much higher level of discrimination than some of the more commonly used plasmid characterization tools, which you see on the first 5 rows of that sort of bluish chart over there. The last 6 rows feature the outputs of the low-seq. So as you go down, down this chart, you see that low-seq can be very highly discriminatory, but it can also be less discriminatory. So you can kind of choose what level of discrimination you want, or what level of discriminatory power you want in identifying your plasmid types. We're also using metagenomics. Right now, it's not used so much for surveillance. It's used primarily in the research realm. We have a lot more work to do to get it to a point where it can be used for surveillance. But the nice thing about metagenomics is that it bypasses the need of isolating microbes, and it gives us a more valid picture of the total microbial community and its resistance gene profile. So because of this, we can now start looking at reservoirs of resistance genes, and we can also use metagenomics to detect the slight changes in risostomes that might occur as a result of stewardship efforts that FDA implements. And so by stewardship efforts, I mean, rather than removing use of an antimicrobial, reducing use of an antimicrobial. So, where there might be slight shifts in the resistance composition of these bacterial populations, metagenomics can be a better method maybe to detect that. The only issue with metagenomics, or one of the issues with metagenomics, is that it requires enough depth of coverage to capture representative sequences. And another big issue, at least on the regulatory side, is that, on the regulatory side, we're interested in what is most risk to human and animal health. So bacteria that are at most risk to human and animal health, what is the AMR profile of those bacteria? With metagenomics, you're going to get a AMR profile of the entire bacterial population in a sample, some of those bacteria may not necessarily be risky or injurious to animal or human health. And so, you know, the regulatory side are saying, well, what are we supposed to do with this data? Well, there are supplemental approaches like long-read sequencing and cross-linking that can help us map those AMR genes back to plasmids and bacteria. And so at FDA, we've been using a metagenomic approach for retail food, animal ceca, surface water, and pet food. And as we're exploring metagenomic approaches, we're looking at two primary approaches. One is the traditional culture-independent approach, which is metagenomics, essentially. And the question that can answer is, what resistance genes are in uncultured or unculturable organisms? But then we're also taking a quasi-metagenomic approach, which is taking that sample and incubating it in pre-enrichments, selective enrichments, so that we can amplify the genes that we're interested in, particularly the antimicrobial resistance genes. And so with that, the question is, you know, are these target organisms in the sample, the targets being those that you're selecting for with these selective enrichments? And then what resistance genes are in those target organisms? So Dr. Daniel Tedeschi has really been driving the culture-independent approach to metagenomics at FDA, and he's done metagenomic sequencing on ceca from swine, cattle, turkey, and chicken. He's also done it on retail seafood and environmental water samples. And as you can see, you know, he's shown that there are shared resistomes between these different sources, but then these sources also have their own independent resistomes as well. His group is also using cross-linking approaches. Hi-C is the name of the approach they use in order to be able to link the antimicrobial resistance gene with the organism and with the plasmid. So that addresses some of the regulatory concerns that I had talked about a few minutes earlier. Dr. Andrea Otteson is the one that's sort of leading our quasi-metagenomic approach to metagenomics. And so, you know, with using different media, you are going to find that you're getting different representative bacterial populations. But it's what you would expect with these different media. So like, for instance, we use RV broth or RV agar to grow salmonella for our routine surveillance. And so in that broth, for her quasi-metagenomic method, most of those sequences are from salmonella. But then again, when you look at the AMR genes, you're also going to get differences that are a reflection of the different broths and enrichment media that you're using. So again, we're weighing, you know, which approach makes the most sense, and based on which question we're trying to answer. Finally, I'm going to talk about the use of AI and machine learning for MIC prediction. So the work in the next few slides is going to be from Dr. Shihao Su. He's developed machine learning models to predict MIC values and track trends in resistance. He uses an XGBoost model that uses k-mers to predict MICs within plus or minus twofold dilution, and also susceptible resistance phenotypes based on those criteria you see. Across all 4 genera of organisms and all 24 antimicrobials that we test in NARMS. This is going to be kind of revolutionary. So again, these are my opinions, not necessarily those of FDA, but once validated, these models could replace susceptibility testing for surveillance. So that's something that, you know, could potentially come out of this. This machine learning and artificial intelligence approach can also be used to identify novel genes or variant resistance genes or mutations, because, you know, since he's using this k-mer method, if the k-mer does not contain sequences for already identified antimicrobial resistance genes, it contains sequences that you know, we've never related to antimicrobial resistance before. And so that, you know, brings us to maybe some research questions, looking to see what other genes are in these k-mers that are related to antimicrobial resistance. So here's a picture of all the models that he's tested. The models can predict MIC with fairly high accuracy. All of them have an accuracy of 85% or more. And as you can see, they do vary by organism and drug. Part of the problem with these models is that you need to have a lot of isolates that are resistant. Well, you need to have a lot of isolates in general, and then you also need to have quite a few that are resistant. And so not shown is the false susceptible error rate, which is the resistant genomes that have been incorrectly predicted to have susceptible MICs. That rate is high for some drugs because there's only a few resistant genomes that we have that can be used in his training set. For instance, there's only 7 resistant genomes for azithromycin in the salmonella model out of the, forget how many isolates he included in the model. But again, these models can be improved when they're trained on isolates with greater variability and resistance genotypes. Another plug for having access to global genomic data, not only the genomic data, but also in this case for the MIC prediction tool, having access to the susceptibility testing data on those same isolates. So this is just a summary of how we have advanced our use of technologies for NARMs. I'm not going to go through it because I'm sure I'm out of time, but basically it captures what I spoke to. And I'm happy to take any questions?
Thank you so much. We build and operate data for AMR surveillance, and not just Korea, but also other countries really refer to the US NARM system for AMR surveillance. And the presentation also covered a genome tracker and NARMS Now, the new system, as well as a resistome tracker. Thank you so much for introducing us into these systems. And you covered a lot of topics, and the topics seem like it requires more time for us, but let us open the floor for questions. Thank you so much for the presentation. In the AI model, you matched phenotypes and genotypes, and there may be a lot of factors in that. For example, there may be mutation and regulatory effects for gene copies, and transcription and translation-related mutations. So there are many situations that affect the correlation between phenotypes and genotypes. So if we look at the structural genes with modeling alone, there may be some limitations. Does the AI model cover these areas, or are there any missing parts of this AI model that you just showed?
The AI model does not incorporate any post-transcriptional sort of modifications. But it does, and I'm speaking out of pocket here because this is not my work, but I do know that he has incorporated the phenotype, genotype analysis into his AI models. And the AI models are not, basically the level of accuracy is the same when he's looking at phenotype, genotype data alone versus this KMER approach.
Thank you for your presentation. I think United States already have integrated the whole genome sequencing data from the One Health perspective. I just wonder if there is any data available analyzing how much of a human AMR comes from food?
I think you'll probably hear that in the next presentation, but we are continuously, okay, maybe not, but we are continuously asking that question. You know, not only are we looking at just the resistance data in general, we're also looking at the trees that are inferred from the genomic sequences, and looking at the relatedness of the isolates that are coming from the animal and retail meat with humans. And so in certain cases, we have been able to with a high degree of certainty, although I wouldn't say 100%, especially if you don't have epidemiologic data to follow it up. But with a high degree of certainty, we've been able to say that, you know, human infections are caused by, or are probably caused by, likely caused by consumption of a certain meat product if we find that the strains in the two are related or clonal. And so yeah, that's where we are with that.
Thank you very much for your very intensive presentations. I'm so amazed about how advanced you are. And I have two questions. First one, listening presentations from yesterday and today, I have learned that thanks to the advanced technologies, now we are able to have more correct data, and AMR is real, and AMR is getting complicated. How do you communicate with the consumers? Sometimes it is very frightening, unwanted truth. So you are working for FDA, so your another role is to communicate with the consumers. So how do you communicate? And my second question is that, okay, you are a developed country, but also underdeveloped country need surveillance. So this kind of advanced technologies should be applied in the underdeveloped countries, or how do you recommend for the underdeveloped countries? Thank you.
Yeah, so the first question, communication, yeah, that is key. And that is one of the nice things about NARMS being a interagency program, is that the agencies work together to develop these communication points about AMR. On the NARMS, so, and there's different ways in which that is communicated. On the NARMS website at FDA, we have interim updates where, you know, we have a emergent finding of resistance, we will communicate that to the public on that website. And again, that's dialogue between all three agencies on what are the most important pieces of information that need to be conveyed, you know, what is going to be translatable to the regular public about these findings. And CDC also has their own web pages where they're conveying similar information and how it might be related to outbreaks. So yeah, that is a piece of this. With regard to the other question you had about maybe LMICs, we would support the implementation of whole genome sequencing in all countries, you know, not just advanced countries, but in all countries. And you know, I do know that there are some mechanisms out there, some groups that are working to promote the use of these technologies in those countries and overcome some of the hurdles that exist for implementing these technologies, such as like cost structures for equipment, et cetera. And so that's something that we certainly support. But yes, if your question is, do I think that all countries should have access to? Yes, I do.
죄송합니다만 시간이
Due to time constraints, I think we would have to take the break session in order to have more questions. Thank you so much.
We have the last presentation of this session. The last presentation will be given by Dr. Caitlin Tagg, working as a data scientist at the US CDC. She's going to be presenting on AMR surveillance and monitoring, new technology and changing landscape. She is working with she's working with the salmonella analysis, and she's using pangenomic data, doing a co-research on that, and she has also published a lot of papers regarding these issues. Today's presentation will be regarding AMR surveillance and monitoring, new technology and changing landscapes. Please welcome her with a big round of applause.
Thank you so much for the invitation to be here. It's a real thrill to be able to share some of the work that we've been doing on kind of developing our AMR surveillance. I'm going to talk about the work of a lot of people and a lot of different groups. I may not have answers to your questions, but I'll certainly put you in contact with the right people. So like was mentioned, I'm also from the NARM system, but I'm based at CDC, so focused on human health. And I wanted to start by giving an overview of the Centers for Disease Control, because it is a very confusing place, even when you work there. So this is just as much like a refresher for me as it is an overview for everybody. So we have 10 centers within the CDC. I'm positioned within the National Center for Emerging Zoonotic and Infectious Diseases. And within that center, we have 8 divisions. I'm over there in the Division for Foodborne, Waterborne and Environmental Diseases. And the NARM surveillance system sits within this division, and it spans 2 different branches, an epidemiology and a laboratory branch. And we do collaborate across those 2 branches. So all the work I'm going to talk about today is based in this division, because we're a One Health foodborne surveillance focused division. But I did want to mention we do have a counterpart in the Division for Healthcare Quality and Promotion. I think that's the acronym. This is an antibiotic resistance coordination strategy unit. They are focused much more on the human health, hospital-acquired infection type work. So we do collaborate, but our surveillance systems are very, very separate and actually quite siloed. So Heather did a wonderful job of introducing the NARM system. It's a tri-agency agreement between FDA, USDA, and CDC. I'm going to elaborate a little bit more on the CDC component and just describe how it really is a very intricate, interactive system that works with a lot of other groups. So we are very connected to PulseNet, our national enteric surveillance system. And PulseNet is tasked with identifying outbreaks and clusters of foodborne illness across the country. They do this by coordinating over 80 different labs across the entire country, working with the state partners to centralize all of the data that comes in. That's the laboratory detection component. We also work with other surveillance systems like FoodNet, which is more on the epidemiology side. So they collect a lot more detailed epi information, like hospitalization or treatments or travel history from the patients that are being infected with these foodborne illnesses. Okay, just a bit of history. So even though they were both born at the same time, NARMS and PulseNet actually functioned quite separately when they started in 1996. PulseNet was focused on DNA fingerprinting using PFGE, and that was done at the state health departments. Whereas NARMS focused entirely on AST, phenotypic testing, that relied on isolates being shipped to CDC to perform that testing. Fast forward 20 years, and we have the introduction of the National Action Plan on Combating Antibiotic-Resistant Bacteria. This was a congressional action plan that came with a budget line that allowed the integration of NARMS and PulseNet systems. What it enabled PulseNet to do was put sequences in every single state health department and train their staff on how to perform whole genome sequencing. This was a great opportunity for NAMS as well, because we were then able to use genotypic resistance to complement our phenotypic data. And now we're in 2024. PulseNet has transitioned completely away from PFGE, is now entirely whole genome sequencing based. NAMS is completely integrated into the PulseNet system. And this has enabled us to expand our collaborations and work a lot more with academic and laboratory partners because we have access to all of this great data. And I tell you what, we do not have the time to analyze it all. So if you're interested in working with this data, please let me know. Oh, an animation I did not realize was there. So how this system works and the integration, all of the foodborne illness pathogens that are reported to PulseNet are nationally notifiable. So this is Listeria, Salmonella, Shigella, sugar toxin producing E. coli, and Vibrio. All of those culture confirmed cases get sequenced at the state. They get genotyped and they have their AMR determinants predicted as well, and that all gets uploaded to the PulseNet national database as well as NCBI. And that's all centralized. This is like upwards of 80,000 isolates every year that's coming through this system. To complement that, we still have our NAMS phenotypic testing. So 1 in 20 of those confirmed laboratory cases gets physically shipped to CDC for phenotypic testing. So 5% of all of the cases of foodborne illness from these organisms across the country. The one caveat to the 5% is that our typhoidal Salmonella serotypes, so typhi, paratyphi A, and paratyphi C, 100% of those isolates get shipped to CDC. So we have a much more complete data set of genotype and phenotype information for those organisms. We have like 20,000 something isolates that have both phenotype and genotype. It's a really wonderful data set. What do we do with all of that data? Well, first, we make it publicly available. So this is the NAMS Now CDC version, which is a different webpage to what Heather introduced. And this has data, WGS data and AST data that is as up-to-date as it can be. The WGS is much more real-time than the AST data. But you can filter and you can also download all of this data by bug, by drug, and by year. So all of this goes into reports. It's also used to inform CLSI and UCAS breakpoints. It is used to inform national treatment guidelines, but it is not used for clinical care. We are not, the predicted resistance is not supposed to be used for patient care. We also report our resistance data in the outbreak reporting. So this is the BEAM dashboard, which is publicly available. It's fairly new, actually. And what you can do with this website is look at the foodborne outbreaks in the US by organism, by vehicle, by exposure, by year, and we're reporting out those outbreaks that have clinically relevant resistance as well in the tiny little print down the bottom. We also put this data into public notices. So whenever we have an ongoing outbreak or investigation, we want to make sure that the public is aware and the public health professionals are aware of what's happening. So we will release these notices that have information about the exposure of the outbreak and also the rates of resistance within the outbreak, confirmed outbreak isolates. So this is predicted phenotype. It's not AST that we put, and that's partially because we have access to more real-time data with the predicted resistance. And we also use it in our alert system. So we have an emerging antimicrobial resistance alert system, the EAR system. And this is a collaborative working group between our NAMS partners, as well as other groups at USDA and FDA and the Public Health Agency of Canada. And we meet monthly. We talk about the numbers that are coming in for the specific alerts that we have ongoing. We talk about whether any action needs to be taken, because if the numbers are increasing, we might want to initiate conversations with the right people to try and do something about that. And we also talk about any new alerts that we want to be introducing. These are things like, a particular gene, MPHA and Salmonella serotype X. I can't actually remember what some of the alerts are. But I have been tasked not to tell you what we're doing currently, but what we are thinking about doing and the new technologies that are on the horizon. And it won't surprise you for me to say that we are looking at long-read sequencing. We've been investing a lot in the last couple of years. And I will say this is because of AMR. You know, I work in the research space, and we needed long-read sequencing to complete our genomes and to study our plasmids. And so I think that initial interest kickstarted the investment in our division for building up long-read sequencing capacity and expertise. One part of this I wanted to mention was the Oxford Nanopore Technology multi-site validation. So this was a collaboration between staff in our division, as well as the Centre for Pathogenomics, which is based in Melbourne, Australia. And the goal of this validation was to do both wet lab and dry lab assessment. So they looked at extraction method and library prep method, and then they also, for the dry lab side, looked at the base caller accuracy. And the wonderful thing about this was that they actually worked with ONT to feed back that information. So all of the assessment results they were finding, they gave back to ONT so that they can continuously improve their algorithms. We want to make sure that long-read sequencing is going to be as accurate as possible if we're trying to use it for AMR surveillance. And one of the things that came out of this was that AMR determinants can be detected at a lower coverage than I think was initially expected. So this is good news if we're trying to develop standardized high throughput protocols. One of the questions of this validation was also the feasibility of using long-read sequencing for global AMR surveillance, and I'll touch on that in a couple of slides. So that work was done by people in our lab, in our team. I also wanted to highlight some of the work that we do collaboratively, which means we give our data to somebody and they do the validation for us, which is a wonderful way to participate. The Global Typhoid Genomics Consortium is a group of researchers, academics, laboratory staff that is being coordinated from around the world, and they have really focused on trying to understand the epidemiology of Salmonella typhi. What they're doing right now is trying to validate the use of long-read sequencing for genotyping and AMR detection in Salmonella typhi. And that is actually just about to be submitted for publication, I think, so it will be publicly available shortly. I wanted to highlight this not because Salmonella typhi is necessarily a foodborne concern for many of us, but because I really believe these global assessments with multiple partners around the world of new technologies and new tools using surveillance data from many national surveillance systems is a really good model for us to be using going forward. So that's why I wanted to point this out. And I'll spend just a few minutes talking about some of the work that I've been involved in around microbial ecology and the ecology of AMR. It's not a new technology per se, but I like to think that it is a new way of thinking about AMR and trying to understand how we got to the situation that we're in right now and maybe predict some of the things that we're going to be experiencing going forward. So when we study AMR in the WGS era, it often looks like this. We build a phylogenetic tree based on core genome targets, and then we map around the outside AMR genes of concern or plasmids. And this is really, really useful. We do it a lot. It gives us good information, but it also sometimes sends us conflicting signals. Like this, here you've got all these kind of random colors around the outside of this tree. Doesn't make a lot of sense. We can't make any kind of good conclusions from this figure. So we are investing in a pan-genome approach, which is using not just core genome material, not just plasmid material, everything in between, the entire pan-genome of these organisms. This is called Jacquard Index Network Analysis. It's a KEMA-based method. I won't go into the technical details, but if you want to ask me, please do. I could talk about it all day. I won't though. So this method allows us to capture both vertical and horizontal evolutionary pathways of these bacteria. So that, to me, is the key way to understand AMR and the evolution of AMR. We also we visualize using a network rather than a tree, which we know is actually more reflective of how bacterial populations evolve, right? So an example of that, we started with Salmonella typhi as the pathogen. And what I'm showing here is a network of over 2,000 typhi genomes. So each grey dot is a genome. It's an individual case of typhoid fever from a patient. And the dots that group closer together are more closely related. And we can do a couple of things from these networks. First, we can study AMR directly. by literally mapping on the AMR profiles onto these networks. So you can start to see which profiles are more common in which groups, and which groups don't have resistance. And then we can also link that to our epidemiological data and our geographic data to find out which resistances are more common in certain places. This has been kind of, in my mind, a game changer for understanding, for linking the epidemiological and laboratory data together in sort of a complementary way. We can also study, using the networks, we can also study AMR indirectly by mapping on plasmid information, by mapping on mobile genetic element information. And that will help us understand the dynamics of how these elements move around. They are the elements that are carrying the resistance genes that we care so much about. So understanding their dynamics is key to understanding and maybe potentially predicting where AMR is going. I will say, again, typhi, I know it's not necessarily a foodborne pathogen of concern. We have looked at other Salmonella serotypes that are foodborne, Salmonella hedar, Salmonella enteritidis. So we are definitely applying this approach to understand and to maybe link some of the human cases with the food animal or retail meat cases, which sort of speaks a little bit to the question that was asked earlier. I don't have anything to show for that though. Now, all of this work that I've talked about is happening in a not static environment, right? Our landscapes are always changing. One of the things that has been the biggest change for us recently is our shift away from PulseNet's shift away from a proprietary software for their centralized database to an open access cloud-based system. That's literally happening like as we speak. I think they launched it last week on Monday. And so it is, in theory, going to be a very seamless transition, but I don't want to undersell how big of a deal this is. This is the biggest technological transition that PulseNet has had since the shift from PFGE to whole genome sequencing. So it's a lot of work from a lot of people. What that means for us from the AMR surveillance perspective is that we've moved from ResFinder to AMR Finder Plus, which is a much more up-to-date curated database. It's the one that's in the NCBI pathogen detection model. And so we have all confidence in using this system. All of our internal validation has showed that our results are going to be as expected. But of course, we'll continue to monitor going forward. We always want to make sure we're refining our surveillance system. The other thing that is changing in the landscape of sequencing is that post-COVID, a lot of countries now have access to sequencing that they did not before. But this is not short-read sequencing, it's long-read sequencing, right? And so all of the established national surveillance systems that have developed protocols are based on short-read data. And what we need to do is develop protocols for labs for their long-read data. And so PulseNet International has worked a lot in this space. PulseNet International is a collaborative group of over 80 countries based in 8 regions around the world. And they're really tasked with developing or standing up a WGS-based foodborne surveillance illness system. This is going to look different in different places, obviously. You can't kind of apply the same thing in every place. And so they're really working to coordinate. One of the main things is technology transfer, so developing these standardized protocols that can be implemented in labs. And that multi-site validation for long-read sequencing that I mentioned earlier is part of this process. They are currently, PulseNet International has conducted 2 trainings in the last couple of years, one in the PulseNet Africa region and one in the Asia Pacific region as well, to implement these long-read sequencing protocols. So AMR surveillance globally is rapidly expanding, which I think is a really, really exciting space. And it has been brought up already, but all of these methods are culture-based methods. And what is happening in the US is the rise of culture-independent diagnostic testing, which is wonderful for patient care, but it does mean the sure and slow decline of cultured isolates coming into our surveillance system. And so what PulseNet is doing is piloting a highly multiplexed amplicon sequencing method to extract genomic data directly from store. They're working with 9 states across the US to kind of validate this. It's promising. We can get detection of the pathogen, detection of the genotype. It's affordable, it's scalable, and it's automatable, which is important for state labs. But we've not yet invested in the AMR component of this. The way to do this is to develop thousands of primers to detect all of the resistance genes that are going to be clinically relevant. It's a big task. takes a lot of resources, and we are not there yet. And I just wanted to end by saying all of these wonderful AMR surveillance systems cost a lot of money, but they also save money. So an economic evaluation was done in 2016 for the PulseNet system. This was based on PFGE technology. So even though it was PFGE, they found that the PulseNet system prevented up to 270,000 foodborne illnesses every year because they were able to detect outbreaks sooner. And this saved over $500 million in associated medical costs and lost productivity. So this is good value for money. Every dollar spent, we get $70 saved for the US economy. But like I said, this is PFGE based. So what we are doing right now, I say we, I'm not involved, is a cost-benefit analysis of the WGS-based PulseNet system to make sure that all of this extra effort that we're putting in is actually paying dividends at the end, right? To make sure we're still spending our money wisely. So look out for that cost-benefit analysis coming soon. And I'll close there. Here's my email address. Please do reach out. I'm always happy to discuss any of this and, like I said, put you in contact with the people that can most speak to all of the work that I've just been describing. Thank you. 감사합니다. I've been practicing all morning.
Thank you very much. So you introduced the phylogenetic tree and also the new Jacquard network analysis. And I believe that there is a lot more to explain and discuss on that. Thank you for introducing it. And regarding the PulseNet 2.0 and PulseNet International, I'm not sure if Korea is participating in that as well. I think in the picture we saw Korea in there. And also the analysis method, the metagenomic approach without culturing. So you introduced a lot of different methods and how this can be effective in preventing diseases. So now we will get some questions from the floor. Thank you for the presentation. So for single cells, you said that you are using the long-read sequencing platform, and for the metagenome sequencing, what platform are you using for data accumulation, long-read, short-read, or hybrid? Or are you using one side? I'm wondering about that.
You mean for the metagenomics, you say the Amplicon, yeah, so that platform is the Juno platform, I believe, is what they're using for the HMAS system. Any more questions about that, I will have to direct you to the project lead of that. So yes.
Thank you so much for your kind presentation. Also, I'm a microbiologist. I'm interested in your analysis tool based on the pangenome analysis. Pangenome is based on, as I understand, based on one species level. It means you have to collect same species and you do somehow check out something using K-mer, whatever, analyze and show the network. But my question is, some family or genus level, they also share the ability, especially in the plasmid. In those kind of concepts, also is allowed to apply those pangenome platform to the genus level. Is it possible to apply pangenome analysis?
So this is a great question, and it really depends on the question that you're asking of your data. So I'll say we use the Jacquard Index network analysis for serotype-based work. It is extremely high discriminatory power, and that's really where we see the value when we're trying to tease apart like a clonal serotype. Salmonella typhi is one of those. I would not recommend applying it to Salmonella generally because you're not going to get as much value out of it, and it's probably going to complicate your picture a little bit. There are plenty of other pangenomic tools that look to understand all of the different elements that are part of a serotype or those that are shared, part of a species or those that are shared across species. So there's so many out there to use, but I'll say this one is very specifically for serotype level analysis.
Okay, thank you for your comprehensive presentation on your work. I think your new technology, it seems to be very cost-effective. And as far as I know, CDC has some representative offices in some developing countries. So I'm wondering if CDC has some international cooperation on AMR surveillance and monitoring, something like that.
Yes, and that is actually a surprisingly complicated question. So I'll say Pulsar International does a lot of work with their regions and their partners within their sort of reference laboratories. I know that there are all of the centers that I showed you at the beginning. There's a global health center that does a lot of work on developing laboratory capacity outside of the US and with their in-office partners as well. And I believe they are doing a lot of capacity building from kind of the ministry level. So I would say Pulsar International it's sort of built from the ground up, but the global approach is working with the ministries to make sure that surveillance is coordinated from a higher up level. So the answer is there's a lot of work going on. It's kind of happening separately.
마지막으로 한 번만 더.
Okay, because of time constraints, one more question.
And it was fascinating information, especially for its potential. And I would have many questions, but I will limit to one. And towards the end of the presentation, where you were mentioning the cost-benefit analysis, especially for us, I mean, I think for many of us, under public funding, it's very interesting. How can we get information about its methodology, especially? I mean, not only the result, but the methodology, so that it could be possibly be applied also at global level or in other, to other tools. Is there a way just getting in contact with you, or is going to be published, or we can hear about that? Thank you.
I'm sure, great question. I have the same question. I'm sure it will be made publicly available, and I'm sure that there will be a lot of conversation about it. I will definitely put you in contact with the people that are responsible for it. I will say, we actually had a visitor come recently from Australia who was doing a similar analysis of whole genome sequencing, and I don't know if that work has been published, but they had the same questions. They want to make sure that the cost benefits they're doing for their whole genome sequencing is worth it. So I think a lot of countries are investing in this specific analysis using different models. So I will put you in contact with the right people.
Thank you.
Thank you.
예.
Thank you. So for the remaining questions, you can ask her personally. And now we will conclude the third session. Thank you.
Thank you to all four speakers for the session 3 presentation. Let's give them a big round of applause once again. We have just finished session 3, all 4 presentations on day 2. We have learned more about latest technologies to contain AMR. We've gained a lot of insights into these technologies. Thank you to Dr. In Sun-ju and all the speakers for answering very good questions. Thank you so much, everyone. Before we move on to the session 4, let us have some quick break time. We were supposed to begin our session 4 at 12:25, but let's resume at 12:30. We will resume our session 4 at 12:30.
And now we will resume with the fourth session of the fourth MFDS Global Conference on Foodborne Antimicrobial Resistance. In this session, we will be discussing the sharing of global efforts in various ways to reduce AMR. We have 4 presentations prepared for you. First of all, I would like to introduce the moderator for session 4. An expert in microbial genomics, and also he's an active researcher in the field of antimicrobial resistance. I would like to introduce Professor Jong-chan Choi from the Department of Biotechnology at Jeonbuk National University as our moderator. Please welcome him with a big round of applause. Thank you. My name is Choi Jong-chan. I'm from Jeonbuk University.
Session. I believe this has been a beneficial conference for all of you is to struggle against the AMR. So I'm gonna proceed in Korean. I want to make excuses.
So now I would like to introduce this session before we go into the first presentation. So as introduced, we are going to be sharing various ways and what international institutions are doing to fight AMR, especially in lower developed countries. We talked about the latest technologies. Sometimes it is difficult to apply this in some countries, and in these countries, we are making different types of efforts, which will be shared through this session. And in this last session, we will have 4 presenters. And now I will introduce the first presenter. Her name is Camille Fletchet. And I think it is a bit different from the talks that we had from yesterday. So she is in charge of dispute settlement. She is the dispute settlement lawyer at WTO regarding phytosanitary issues. She has studied in University Paris 1, Saint-Sorbonne, and University Cologne and King's College. She studied law. And she is working with national disputes, working with advices and settlements. Please welcome him with a big round of applause.
Thank you very much for the introduction, and thank you to the government of Korea for the invitation to speak at this conference. You said it, it's going to be a bit different from what we've heard so far, and I have to say I feel a bit like an oddity speaking as an international trade lawyer among so many scientists, researchers, and like true experts in the field of AMR. So as you will have heard from my bio, AMR is not my specialty. I work in the World Trade Organization, but the WTO does a lot of work to support countries who are developing policies to fight AMR. So I'm here to talk a little bit about the tools that exist in the WTO on AMR and the work that we do. I want to also do a little disclaimer that my remarks today are here on my own and do not necessarily represent the views of WTO members or the WTO itself. And also to say right from the beginning that the other side of the coin here is that arguably international trade is also part of the problem in AMR, as the increased movement of goods, including agricultural products, enhances issues relating to AMR. But before I talk about the tools that exist in the WTO to help tackle AMR at the global level, I want to say a few words about the institution for those of you who might not be very familiar with it. So it's a relatively recent institution. We're celebrating 30 years, but we have a very broad membership. 166 members covering 98% of world trade. So almost all of the world trade is covered by our membership. And I think the map here speaks for itself. In green, you have all of the countries that are WTO members. So when we talk about international trade, WTO is really at the forefront. Now, what does it do? It negotiates trade rules, more or less successfully. But it also looks at the implementation of existing trade rules and monitors the implementation. And it also deals with settling disputes among states, among members, as they relate to international trade. So what I'm going to do today in this presentation is talk a little bit about those trade rules that help tackle AMR, or that may be relevant to the AMR discussions that we've been having. Now, if we look at the interlinkages between international trade and AMR, there are many. The first thing that comes to mind from a WTO point of view is the access to medicine. And in that space, WTO rules have done a lot of work to provide more equitable access to quality medicines, including antimicrobials. They've done so by reducing tariffs. So now on average, across all types of different economies, tariffs on pharmaceutical products are well below 5%. It's also facilitating access to medicine by allowing certain countries to produce under compulsory licenses, generic medicines for their own domestic production and also for export. WTO trade rules also stand for fostering innovation to develop quality medicines and alternatives to antimicrobials. Another relationship between AMR and trade relates to WTO rules that support policies that are put in place by our members to protect against foodborne risks. And those are the ones that I'm going to focus on today. So just to say here that there are many different agreements, if we look at the set of WTO rules that could be relevant to AMR. But because the linkages are stronger in that space, and also because it's my area of expertise, then I'll talk to the rules on sanitary and phytosanitary measures, the SPS agreement. The scope of the SPS agreement is shown here on the slide. It has, broadly speaking, three main areas of work: food safety, animal health, and plant health. And obviously, AMR is really at the interlinkages between all of them. The types of measures of domestic regulations that may be subject to the WTO agreements are many, and they're varied. So it could be, let's say, a restriction on the use of certain microbials, the ban of the use of certain products, regulations that impose certain thresholds in terms of residue of drugs used in animals before the food products can enter the country. It could be in the form of certification scheme, testing requirements, or safety requirements that could apply to alternatives, alternative feed, as those that we've heard about yesterday. What matters is that the measure is taken to protect against an SPS risk and that it may affect international trade. So at the WTO, we're concerned with those types of policies to the extent that they may affect international trade. Now, one thing that I wanted to show you is this graph, which shows the trade in agricultural products over the years. And to say it very simply, what we can infer from this is that it's on the rise. And with an expanding population, it's going to continue being on the rise. So those domestic policies that may be subject to the WTO agreements, they're not going away. Even they're going to gain in importance in the years to come. Now, what I've said, there is this agreement in the WTO that may apply to domestic regulations that concern AMR. So what does this agreement say? It recognizes first and foremost the space that members have to regulate, to protect legitimate interests. So there is a right to regulate, to protect human, animal, and plant life or health. But that right has to be put in balance with the need to avoid unnecessary barriers to trade. One way to achieve this is to use international standards. So the presumption here is that if you base your domestic regulation on existing international standards, then that regulation will not create an unnecessary barrier to trade. And that's a very important part of what the WTO rules stand for. They're really there to promote global solutions through the use of international standards. In the SPS space, we recognize the international standards developed by 3 international standard setting bodies: the World Organization for Animal Health, IPPC, and so the International Plant Protection Convention, and Codex. And all of those 3 international standard setting bodies do a lot of work in the space of AMR. So those are the international standards that are being promoted in the SPS agreement, embedded in the SPS agreement, and members are encouraged to use them. So what is it exactly that the WTO rules say, specifically with respect, or that may apply for the Codex AMR guidance, is that members, governments, have to base their SPS measures on science. And the first avenue to do that is to base the SPS measures on international standards. So members shall use international standards, including Codex standards, as a basis for their domestic regulation. And if the domestic regulation conforms to those standards, then there is a presumption of consistency with other international trade rules. So that's a big incentive for members to use those international standards where they exist. If they decide to not use those international standards, then members have to conduct their own risk assessment, which is obviously a more cumbersome exercise. But when they do so, they also have to take into account the guidance that may exist in terms of risk assessment techniques, including Codex guidance. So there are 2 avenues to use international standards when governments are developing domestic regulation on AMR. Now, the one thing that I want to strike here is that Codex guidance, as other international standards, they're voluntary, right? But because they're embedded in an international trade agreement, they are strengthened because the agreement itself, the SPS agreement that we have at the WTO, it is binding upon members. So the role of the agreements, of those trade rules, is really to provide more strength to the international standards that are developed by Codex, WOA, and IPPC. Now, another thing that WTO trade rules stand for is to support more regulatory cooperation, including on AMR. So even when international standards are not being used, members have an obligation to notify their draft SPS regulation to the extent that it may affect international trade for comments by their trading partners. So it's almost like a consultation process with trading partners around the globe when you're developing regulation domestically that may affect international trade. So with this, it's really to help those who are putting together legislation or regulation on a particular issue, to help them get comments, get questions from their trading partners, and to revise their drafts along those comments. And if we look at notifications on the SPS side, so those are the draft regulations that are being notified every year to the WTO. In recent years, there have been about 2,000 notifications that come in. Looking at the database that we have, only 37 of them specifically refer to AMR. But obviously, there are many regulations that may not specifically refer to AMR that may be relevant in the AMR context. And here on the slide, you have a few examples because I wanted to showcase that those notifications come from all around the world. It's not only a certain members, certain developed countries that are notifying, but we have a lot of notifiers around the world. So recently, Morocco notified a regulation on substances banned from use in livestock. We had a recent notification from Malaysia, which I shared with a colleague from Malaysia yesterday because I was very happy to see a presentation from Malaysia on AMR, and a recent notification from North Macedonia introducing their program on AMR. So if you're interested to see what other countries are doing in terms of regulations that may come into place in the near future, again, it's draft regulations that are being notified. We have a platform where all of that information can be found. It's the EPING, SPS, and TBT platform. Now, how else can the WTO help? We have a dedicated committee dealing with sanitary and phytosanitary issues in the WTO, and it's essentially a forum for members to discuss. So it acts first and foremost as an information sharing hub. And members and observers can share, for example, information about new regulatory efforts on AMR. They can share information about the technical assistance they're providing. There were a few questions in the last session about what does it mean for developing countries. So this is also a platform where members can share what they're doing in terms of sharing different systems, different technologies, and building capacity in developing countries. They can share information on financial support that they're providing to different organizations, including on AMR. And so, for example, this could be a great opportunity for the Korean government to share information about this conference so that it's essentially a platform to raise awareness to all regulators around the world about what is happening on AMR today. There's also an agenda item on monitoring the use of international standards. So each international organization is monitoring the use of their own standards, but in the SPS committee, we're also tasked with monitoring the use of Codex guidance, WORA standards, and IPPC standards. So this is where really Codex could come in to explain how their guidance is being used, but also members who think that there is guidance missing and some efforts are needed could bring it to the attention of the committee. Or if they're thinking that the guidance is being improperly used by certain members or not used enough, then that would be a good platform to raise that. One last and important thing that we do in the SPS committee is to manage trade tension. So I'm a dispute settlement lawyer, so I love disputes, but not everybody does, and it's certainly the last resort for countries. So in the SPS committee, there's a mechanism that allows a member to raise a concern about a particular regulation that is being put in place by another member. And doing that allows to garner support from other members that may have similar concerns. It's also allowing a member to have a conversation at the multilateral level when it concerns a global issue, right? So in the space of AMR, that would make a lot of sense to have that conversation with the entire membership of the WTO around the table. We do have concern that is currently being discussed on AMR in the WTO. It was raised by Argentina and the US a few years ago. And it's supported by others: Australia, Brazil, Canada, Chile, Colombia, Japan, Norway, Paraguay, Uruguay. So what's interesting here is that it's supported from countries that reflect diverse economies, diverse types of economies, and from different parts of the world. So it's really they're raising together a concern and sharing issues that they have with one domestic regulation. So in this case, it concerns the EU review of its legislation on veterinary medicinal products. which has a number of implementing acts that have just come into force. So it's a very current discussion, even though the regulation itself dates back to 2019. And those who are raising the concern are essentially asking the EU to consider a number of things. First of all, to adopt an approach that might be more flexible, to recognize that diseases do not affect countries in the same way all around the globe, and that while certain drugs may not be needed in the EU, they might actually be needed elsewhere to tackle important diseases. They're also asking the EU to really consult on those regulations, to consider adopting international standards rather than do something that they consider is more burdensome or more restrictive than those international standards. And they're asking for a longer transition period. So looking at the regulation, obviously, if you're thinking about animals that have been treated before the regulation came into force, like how does that affect the products that are then exported after the regulation comes into force? So we expect that this again will be discussed at our next committee meeting, and certainly not going away from the agenda. So that's a current discussion that is very relevant to the topic we've been discussing in those past 2 days. Apart from the work that we do in the SPS committee, the WTO is also coordinating efforts with other key actors. It was part of the ad hoc interagency coordination group on AMR that had emerged from the first UN high-level meeting on AMR. And so obviously we will be following what will be happening this week at the second such meeting on AMR. And we're also providing input on other agreements that are being drafted by other organizations. And I wanted here to point out the WHO draft pandemic agreement, because a lot, like some presenters mentioned the fact that, you know, AMR is a silent pandemic. And yes, it's true, and it's being recognized as such in the efforts that are out there to draft a new agreement to increase the preparedness and response to new pandemics. So if there was one thing that I wanted to really say as part of this presentation, which again, I realize is a bit of an odd topic compared to what was discussed in the remaining parts of the sessions, is that there are WTO rules that matter for AMR, and they provide tools in the fight against AMR to, first of all, rules that strengthen international standards that exist, including the Codex guidance that is at the very heart of this conference. There are rules that foster transparency for more regulatory cooperation on AMR. We have a system to help members, countries deal with AMR-related trade frictions, and we have discussions that are happening right now at the WTO on the topic. And you have really the possibility, or governments really have the possibility to use the WTO as an information sharing hub on AMR. So I would really encourage governments to use that platform to be able to share information, including on this conference. So thank you very much, and happy to answer any questions you may have afterwards.
Yeah.
Thank you so much for the presentation. I would now like to take questions from the floor.
Thank you very much. I don't have any questions because your presentation was very, very clear. I have just one comment. I'm Codex Secretariat Myung-Shin Choi. Codex and WTO work together. Codex serves as an international standard in terms of food safety, but also we are working together as observers. Whenever there are SPS meetings, we participate and support WTO's work. And when we worked for Codex standards on AMR, WTO participated actively and supported us to develop 3 important guidelines. So I just want to say we work together, we collaborate always. Thank you.
Sorry, I realize this was not a question, but thank you for the comment, and you're absolutely right. Like, we do not operate in a vacuum, because in the end, organizations are so linked, right? because the SPS agreement is built on those international standards that are out there. So yes, thank you.
예, 또 질문 있으면은
If you have a question, please raise your hand.
Welcome to have this different perspective in this technical meeting. And we do hope that the trade concern will not lead to a trade dispute. We have enough disputes around the world. We don't need that. It was my own ignorance to clarify a terminology. When you said the SPS notifications, I didn't know this specific terminology in this context. It sounds like a good thing. Is it like a country does something and notifies you, we are doing this? Is it like an information sharing? That's the goal of a notification. Is that it?
It is, but it's not only about sharing information, but it's about getting comments from other trading partners and taking those into account in your regulatory process. So in the same way that you consult domestic stakeholders when you develop regulation, you have to consult your international trading partners when you develop regulation that may affect international trade. So it's more than sharing information, it's also getting comments and amending your draft regulation to take those comments into account if you consider that they are relevant and pertinent.
혹시 또 다른 질문 있으십니까?
Any other questions from the floor? I have one question. As far as I know, WTO, when there is a dispute in food sector, WTO refers to the Codex guidelines. But what if the Codex guideline does not tackle such area or field, then countries have to do their risk assessments on their own. But as you know, risk assessment reports contain very technical knowledge and content. So do you get risk assessments evaluated by experts, so third parties, or do they do them independently on their own?
It's a very good question, and here we're at the interlinkages between, what the rules say and the science behind a given measure. So when there is a dispute, then absolutely there are experts that come into play, sometimes appointed by the governments themselves. And if there's really a full-blown dispute with quasi-judges being appointed to decide the issue, then they would appoint their own experts. So what we would do at the WTO is that we would consult with Codex and ask them to give us a recommendation or a list of possible experts that we could then bring on board to help evaluate the risk assessment that was conducted. So the answer is yes, we don't do this on our own, thankfully.
예, 마지막 질문 하나 더 받겠습니다.
Thank you so much for the presentation. AMR is becoming one of the crux of the dispute in the food sector, and EU regulations can be one example. And as AMR becomes a topic of conflict, it seems that sharing monitoring activities on AMR between countries is very crucial. But there is also at the same time that countries are concerned that this sharing information can make conflicts more prominent. So what is the position of the WTO in this respect?
So I don't know if it's necessarily if there are necessarily more conflicts now on AMR. There's certainly more of a discussion on AMR. Even if we look at the current discussion about the EU regulation, at the moment it's very much about an exchange of information, certain members complaining about certain aspects of the regulation, but it's really about an exchange of information. But going back to your question, I think in terms of sharing the data and sharing the scientific information, what the WTO rules say is nothing specific about that per se, but they do say that members have to engage in technical assistance activities, for example, or they have to make sure that their markets can be accessed, so they have to help other countries, in particular developing countries, in accessing their markets. So if they're developing a regulation that affects importers from exporters from developing countries, then they would have to provide assistance upon request or consider providing assistance upon request to help develop those capacities. So we don't have specific rules on the sharing of data in the SPS space, but there are rules in terms of facilitating market access for developing countries and facilitating technical assistance in that regard.
예, 다시 한번 발표 감사드립니다.
Thank you so much once again.
Now let's move on to the next presentation. The next presenter is Dr. Jorge Pinto Ferreira. He's working as a food safety officer at FAO. Jorge Pinto Ferreira, Dr. Ferreira, has studied MRSA epidemiology at Duke University. And also, as I have introduced, he's currently working as the food safety officer at FAO. Please begin the presentation. Please welcome him with a big round of applause.
Good morning, and thank you very much for the invitation to be in the conference. Congratulations on the excellent conference. It's rare to see such a foodborne AMR technical conference, and it is a pleasure to be here, and very thankful for the support of the Republic of Korea of our work and ongoing work that other colleagues from FAO will present in further detail. So my presentation will focus on different aspects of the FAO work that we are doing on AMR in agri-food systems, provide a quick overview of what we've been doing and will be doing in the future. For those of you that don't know, the FAO is one of the many specialized agencies of the UN system and leads the international efforts to defeat hunger. And I was previously the deputy head of AMR at WOA, and one of the main differences that I see between one and the other is that the FAO does have a very strong presence in the countries, with about an office per country, more or less. So a strong membership like WTO with over 190 members represented. And regarding the safe food and the food safety work that we are doing, I guess the motto is, if it's not safe, it's not food. And sometimes we tend to neglect or ignore that aspect. And so the safe is there highlighted in red to remind us all of that, how privileged we are to have safe food most of the times. Now, focusing on AMR, this diagram does not intend to be simple, and I think it demonstrates well the complexity of the challenge that we have and our AMR is. So this diagram is the internal FAO diagram of all the departments that are working on AMR inside FAO. So that tells you how complex it is, even inside FAO, to work on it, and the need for this multi-sectorial collaboration, the need to work outside the silos, and so on. But it does give an overview of the different divisions inside FAO that are working on AMR and how complex it is sometimes to get to the consensus and move forward. We do have an action plan that goes until 2025, and I'll cover some of these things, some of the tools that we are working on. There's Sophie belongs to a reference center of AMR, so we have 9 at the moment and received a few more. There's only so many that we can have, so at the moment we have 9. We are supporting many countries implementing their national action plan. We have these 2, for example, the progressive management pathway. I'll speak more in detail, etc. So this gives just an overview of the work that we do and the action plan. Part of it is the scientific advice, and my colleague from Myeongsing will speak more on the codex work that we do. So there's some colleagues that are working on GEMRA and JECFA, for example, for a lot of risk assessments that then report to codex and then the members of the codex. And Danielle yesterday mentioned this meeting on, for example, on expert meeting on alternatives, which report is now in the final stage to be public. So it's just one of the examples. We do host many expert meetings at FAO. And this was one of the examples that we did last year in July. Other works that we've been doing, antimicrobial use in plant production, for example, is one of the, it's not new, but it's something that we put more interest recently. And actually this morning was discussing with the colleagues from different divisions. we will send, for example, a new letter to the countries to collect more detailed information of antibiotics use in plant production. This was an area that was not so familiar and not so explored. What we realized that many countries were simply doing copy-paste from one year to the other and say, well, these are the pesticides that we are using in plant production. And we wanted to know more about that. So now we have a new letter that we'll send to the countries saying, can you be more specific and tell us if you are using antibiotics in plant production? And that will lead us. Of course, these things take a few years to get the right numbers, but it's something that we have been working on. Then alternatives, I spoke. We published this week a paper on the substandard and falsified medicines or veterinary medical products. This was work done in Rwanda, and we found that about 10% of the samples on trimethoprim sulfur were substandard or falsified medicines. And if you want, then we can speak. It's quite challenging to do this work because, for example, first we cannot fund the purchase of illegal drugs, as you can imagine. Second, we cannot import drugs that are illegal because we can be accused of trafficking drugs. So it's a very tricky work, a very meaningful work to do, but very tricky to do. And that's when we realize why nobody had done it before. It's not an easy work to do in the field. My colleague Alejandro will speak in detail about the InFarm data platform. It's a new thing that we have. Very proud of it because there was a big gap on this at the global level on having a database on antimicrobial resistance in animals and antimicrobial use in plants. So we have about 30 countries that reported already the data to this database. And again, this was a major achievement. It was recently done, and we are happy to do it. And then some of the other tools we have listed there on the left, and Myung-Sing will speak about the ACT project. We developed a tool to monitor the implementation of the Codex AMR standards or texts at the country level, and that's what the ACT tool is about. Some other things on the capacity building. The Fleming Fund collaborates a lot with us. We do, for example, many farmer field schools under the support of the Fleming Fund. And actually, we will go in about 2 months to Cambodia to have a regional meeting with the Fleming Fund to coordinate better the works that we are doing together. I spoke about the risk assessment, and the whole genome sequencing was spoken in detail already during the day of today. We did host a meeting last year of about 20 countries, representatives of 20 countries, to speak about whole genome sequence, not necessarily AMR, but whole genome sequence and food safety purposes for it. I think it was very well received, and they are supposed to meet next year to see the follow-up. Once they went to Rome to learn how to do it, did they do it? So that's always the purpose of the training, no? Did they do it when they went back to their countries? So I'll speak in detail now about two of the major initiatives that we have going on. One is Renofarm, and that I'll speak in detail. And the last thing is the multi-stakeholders partnership platform on AMR. The rest, for example, we have a leaflet or a brochure on the economics of foodborne AMR, and it is something that we've been working on more recently as well. But I'll speak more in detail about the Renofarm and the multi-stakeholder partnership platform. So this is an overview, and again, the beauty of AMR is that it's complex, and every time that you try to do something on AMR, it tends to be complex because it's big, and it's very pleasant for me to go to countries, for example. And in the past, when you went to a country and you wanted to do something, as long as you had the Minister of Health on board, you would be able to do something. Or if you had the Minister of Health and Agriculture on board, you got the green light and you could do something. Now, it's different. You have many stakeholders on the table, and that's very good. That's the way it should be, because we know that it is multi-sectorial. It makes the decision process slower and more challenging, because you need people on board, and that's a good thing. But it just makes the challenges, on one hand, we know the economic impact that it has. We know how many people are dying of AMR, and then we need a long time to make decisions. And this is the current struggle. But the fact that we have all these stakeholders on board is the way to go, and we are happy to have it. And this summarizes it well. We have a colleague in HQ working a lot on this platform, Nelea. She's leading it, and you see that the aims to promote a shared vision for action to tackle AMR, to facilitate information sharing, and to support concrete actions. So this actually, if you have been following the AMR work, it was one of the 3 structures that came out of the interagency coordination group together with the Global Leaders Group that has been quite active, and you see a lot of things coming from the Global Leaders Group. And then there's the independent panel of evidence on AMR, and I think of the three, this is the one that hasn't really taken off. Probably it will be the next one to take off. So this is information about the stakeholder partnership platform, and this is already, again, working. And there were some things on AMR that were just dreams or wishes, and this was one of them, but now it's active. It's like the InFarm platform. It is a reality, and these are good news. Sometimes we need a lot of good news on AMR. Now, the final notes on the Renov farm. So the name is long. Reduce the need for antimicrobials on farm for sustained agri-food systems transformation. And it's a 10 years initiative. So it started last year. The official launch was this year, but it lasts about 10 years, so until 2023. And you see there a lot of the colleagues that are working on this initiative, led by Jung-Xia Song, our colleagues at HQ. And the word, if you pay attention to the words, and on AMR, the terminology matters a lot. It's not about just reducing the use, it's about reducing the need to use. And it seems the same thing, but it's not the same thing. So if you pay attention, that's the goal, to reduce the need to use antimicrobials. The launch was in China in April, so relatively recently. We had this big initiative there to officially launch it with a public statement at the end, etc. So the meeting, I think, it was quite useful and productive. And you see if you might see 5 Gs when you refer to Renov farm. The Gs, them coming from good production practice, good alternatives, good connection, good incentives, and good health services. So these are the 5 Gs that you'll see when it comes to Renov farm. I think the targets are very important, and at the end, probably that's what you will remember. That this means that this is what we'll be working a lot in the next 10 years. We want 100 countries participating in the initiative, so the Renov farm initiative, with a national action plans for AMR fully implemented in food and agriculture. And this is very challenging. It's a very ambitious target because many countries, I guess most countries do have now a national action plan. The vast majority, if you look at the tracks data, most countries do have a national action plan. But even some of that we are directly involved, sometimes they do have a national action plan, but it hasn't been officially endorsed. In some of the countries that Myung-Sing will present on the ACT project, we haven't reached that point. The document is written, but it's not endorsed by the key ministers, and that's a battle that you need to fight until you get it endorsed. Once it is endorsed, then it's time to implement it, and that's the next challenge, the next hurdle that we face. So having 100 countries fully implementing food and agriculture, I think it's quite ambitious, but it's good to be ambitious and have this ambitious target. Then a lot of the work will be 50% of the animal and plant health workers from participating countries are trained. And now in the last working group meeting of FAO on AMR, we're discussing the curriculum. So there will be a lot of trainings coming up, led by FAO. And many of you probably, the reference centers will be involved. Other colleagues from other countries might be asked to collaborate with us because we thought the education, I think the education leads to reduction of the need to use if people know what they are doing. So there will be a lot of trainings coming up. And the third is that 80% of the participating countries contribute data to InFarm. InFarm is this database that I spoke about that my colleague Alejandro will discuss in detail in the next presentation. So having countries participating with their data is essential. Until a few years ago, and even now the reality is, if you try to see global data of AMR, it's super tricky to have. And the initial goal is not even global integration, it's global display of AMR data. And if you get to that point with InFarm, I think it's a good starting point because baby steps sometimes are needed. If you get a global display, then we can aim to the global integration. So some of the things, action accelerators, some of the things that Renov farm will involve, a lot of education, as I said, behavior and social approaches, and this is something that in the past, I think it's fair to say that we tended to neglect the social sciences, the sociology, the psychology, the anthropology side of AMR, and now it's high in the agenda, so we have a lot of colleagues working at HQ on it. It does involve public and private collaborations, and I was in Australia last week, and I was very pleased to see the private industry at the roundtables discussion in AMR. A lot of the discussion in AMR was about human health, maybe agriculture, a lot of government working, but then the private sector was missing on the discussion. And that was a good example of collaboration between them. We saw a lot of good research in this meeting already, so of course research will be part of the story. And youth. At FAO, youth is a big deal. There's a lot of events for youth, initiatives for youth, and I think we will keep having a lot of that. And I think that's good news. It's wonderful to speak with you. I think some of my favorite talks is with kids, because they think very straightforward, and they don't have these complications in the minds that we all have. We know immediately the problems that we'll face, and they don't. So they always have these creative ideas. And speaking with kids is wonderful about AMR. The core principles of Rena farm support, inclusiveness in the sense of we cannot leave sectors behind, and some sectors were neglected. The plant production is an example. Sometimes agriculture was seen as, well, there's this and this and that, and aquaculture. So the point is that we need them all on board, and the environment, for example. Yesterday we were discussing the involvement of the environment. So these sectors will be involved. Sustainable approach and action-oriented. I think, for example, when you say we need data collection, this is a very action-oriented. We need trainings, this is another action. So hopefully this will be a reality. And there was, of course, a linkage with other work. For example, the farmer field schools, many of them funded by the Fleming Fund. The virtual learning centers. Last week, we published a new e-learning course on antimicrobial use. It's publicly available, so highly encouraged to please disseminate it. I think many of the things that we do we all have a lot of resources, and we don't necessarily disseminate them and use them, and we try to reinvent the wheel. And I think on Renner Farm, we can do better on that sense. Everyone else, and so the Renner Farm will offer training, technical support from the FAO reference centers, and I think it's something that we can do more. The reference centers really have a lot of technical knowledge that we can use more. There's a lot of tools inside FAO, perhaps even too many assessment tools, but we do have a lot of assessment tools. So, and some countries do need that assessment as a starting point, and so that they know where they are, they know what's missing, and then they can follow up. So, for example, these are some of the things that we do, training programs, and as I said, sharing platforms that we already have. And the benefits, without trying to convince you, are here some of the things: the knowledge and experience sharing, enhanced impact of AMR on agri-food systems, collaboration, cost-effective and sustainable way, etc., etc., etc. So at the end, this is it: better farms, safer products, and happier farms. One of the countries that has been like leading this initiative is Indonesia, and they were the first ones to have more actions-oriented activities. So these are pictures from, for example, from the farmer field schools done under this Renner Farm initiative at the field level in Indonesia, and the feedback that we got was very positive. Where we are now, we have about 100, early this month, we have about 190 members with 74 organizations and 114 individual members, and I think the numbers has been increasing, and we do need this. It's very good to see the interest from different countries participating in the initiative. So it's easy to join, and I think it's a collaboration too. Everybody that joins can take something out of it and probably give something to the initiative. That's it. I'll stop here. Happy to take any questions. Thank you.
Thank you for your presentation. So can we have some questions or comments from the floor now?
Much for the presentation. It's great to hear about these initiatives, and I'm curious from your perspective where you sit. You see a lot of what's going on in the world. All of the initiatives that are coming, internal, external, international. Are we filling gaps, or are we doubling up on efforts? And can we better put our resources somewhere else?
No, I fully agree, and sometimes it's just that. Like I was in Australia last week, and I did, and I can say it here. I said, well, we have a project funded by the Republic of Korea. It's helping the neighbor countries, and I find it a good initiative. No, it's very altruistic for a country to support other countries, and I gave that example. And the initial reaction was, well, we thought about this as an internal, national initiative, but in fact we can help other countries. And when you speak to colleagues, that came exactly out. We have a lot of tools, brochures, awareness materials that we can use in other. You don't need a new brochure saying AMR is this, antimicrobial growth promotion is that, e-learning courses. We have a lot of materials, kids for comics books for kids. All of these things have been done. So there's no need to waste resources doing those things. So I think the initiative, the fact that it's focusing so much in training, can help with that, putting together different repository of different tools, different materials that can be used. Because as you said, there are some gaps out there, but not as many as we think. And it's a matter of using better the resources that many countries have already developed.
예, 최 박사님.
Dr. Zhou?
A question for you about the trainings. And so, you know, I imagine that each country's situation is different. And so these trainings really need to be customized for that country. So how does that happen? Are you, how does FAO working with people on the ground to do the training? And are there kind of standards that you're making sure are implemented in all the countries that are undergoing the training?
No. So one of the first things is the development of the curriculum, the full curriculum that we want people to be trained on AMR and antimicrobial use. So that's the beginning. And then it is about twinning programs, for example. It's making sure that there's a lot of highly developed countries that can train and share materials with others. And as you said, the gaps will be different. So we'll make sure, that's the goal of the initiative, to make sure that we pair the ones that need more with the ones that already have that developed. Yes. So that's the plan.
예, 다음 질문은 바로 뒤에, just behind the.
Next question behind of you.
Add what George said. In terms of duplications, under the FAO, there are several projects. Our aim is not to duplicate, but to complement each other. So for example, at the project, we have been using a lot of tools what FAO has developed. And in terms of training, it is important to meet their eyes. So first step is to assess where they are. So based on their needs, we have a lot of tools, but we have to adjust our tool to meet their needs. This is what how FAO is working.
Just next to you.
Thank you, Yunshin, and thank you, George. I mean, you provided a lot of information. And thank you also, Catherine, for your question, because that provided me to add another little piece of information. Not only all our resources, I think, as George says, are available online, but we have this also mailing list and ways to facilitate the sharing of information. So do reach out to us, George and myself from Yunshin, to be added. But another thing we have not mentioned, for instance, we do twice per month webinars where we give everybody, I mean, scientists or people working on AMR, the possibilities to inform about the work they're doing. And I think that would be very functional to what you're saying, finding out what others are doing to avoid, replicating the same work, benefiting from results from others and possibly using resources in another way. So that would be a good way to networking, sharing information and knowledge. So again, we're always interested to hear about good experiences, good research. Get in touch with one of us and we will be happy to provide you that kind of platform to inform and be informed. Thank you.
예, 감사합니다.
Thank you very much. So one last question. Thank you for the presentation. Regarding the Renu farm, so you introduced that this is a 10-year initiative. So I think we have a lot of expectations as it is a new initiative. And there was one thing I wanted to comment on and also ask you a question on. So up to now, when we are using antibiotics on animals, we want to reduce the use. But you emphasized reducing the necessity of antibiotic use, and that was very impressive. But when when we want to have effective policies, I think we need to be able to share the benefits to all of the stakeholders. To have something in public interest, the members involved in all of that, we cannot have anyone facing losses because they're doing something. So if we are reducing the use of antibiotics by 50%, then this can lead to profits in some areas, and we can also use alternatives. It's the same in Korea, and non-antibiotic use. This can add value to the products that are made in farms. But if you have higher value, then the consumers need to recognize that there is higher value and be willing to pay more for that. But sometimes that is not the case. So sometimes compared to the effort, you don't have that many results. So since you have been working with this for a long time, is there some kind of a way you can raise motivation for the stakeholders to participate in these kind of initiatives? So regarding just the training, I don't think training is enough to give benefits.
Good points. I think you summarized very well the challenge that we have been facing now of this systems thinking. Now is the new trend to think about systems thinking, And I think a lot of, sometimes as you said, people did something in the past with good intentions without ignoring the consequences up or downstream. And this is the system thing that, because as you said, sometimes you do something you expect that the consumer will be willing to pay for that. And we actually finished a pilot study now in the US, in a university campus. How much would the consumers be willing to pay for antibiotic-free, keeping it simple, antibiotic-free food? And of course, when you do a pilot study and you ask them, are you willing to pay more for antibiotic-free food? They will say yes, or we are willing to pay more. And now we will reproduce that in a bigger country. So trying to address your point, it is challenging to show that the challenge of AMR is exactly that, to convince people that it is worth to invest, because it's very silent or it's hard to prove. But it is, as you said, awareness is not enough. Training is not enough. Just because you speak about it's like going to the gym or saving money for the retirement. It's always, we are aware of those things, or eating healthier. AMR is one of these examples that we can see the benefits long term, but in the short term, it's harder to convince someone to do it. But that's our role, to express the system that we are working on. And I think it's showing the benefits to the different stakeholders, that everybody benefits from this. Speaking with different people, sometimes people are more sensitive to the death, life-death, like the number of people dying, and this speaks to them. Others are more sensitive to economic values. For example, this means money, and they are sensitive to the money values. And for example, some are very sensitive to the environmental factor. They say this impacts the environment, so you should care about it because it matters to the environment. And different cultures and different people are sensitive to different things. Speaking, for example, with the chief veterinary officer of the UK, and I asked her, what works? And she said, well, we speak with farmers and we say, this benefits your family. If you use antibiotics better, this benefits your family. If you think about the health of your kids, this matters to them. And sometimes these down-to-earth, one-to-one conversations make all the difference when people see the benefits for themselves. This doesn't mean that they are selfish, but it means that they see the benefit of doing something, of reducing the need, or reducing the use of antimicrobials. And I do think that everybody has a role on that. I think many of the conversations on AMR tend to be at the extremely high level. See, now we have the high-level meeting at New York, but the down-to-earth citizen, at the consumer, at the supermarket, doesn't care a little about the high-level meeting in New York. They think about the price that they pay of the food at the supermarket. And it's our role that have the privilege to come to these meetings like this to translate this complex message to the consumer that goes to the supermarket.
예, 발표 감사드립니다.
Thank you very much for your presentation. Please give him a warm round of applause.
예, 다음.
For our next presentation, we have Alejandra Dorado Garcia, Unfortunately, he was not able to join us in person, so he sent us a video presentation instead. Let us watch the video. Dr. Garcia is a veterinary epidemiologist. And he studied at Complementa University. In 2018, he has been serving as an animal health officer at FAO. Let us now watch the video from Dr. Garcia.
My name is Alejandro Dorado. I'm a veterinary epidemiologist working as coordinator for AMR surveillance activities at global level from the FAO headquarters in Rome. My responsibilities include the development and implementation of digital services for enhancing capacities of countries for AMR surveillance. And today I will be talking about the International FAO Antimicrobial Resistance Monitoring System, INFARM, as a practical approach for the implementation of the Codex guidelines on integrated monitoring and surveillance of foodborne AMR. Pathogens in food and the food production environment have become increasingly resistant to antimicrobials, resulting in infections that can be difficult or impossible to treat. To address this concern, Codex texts provide a risk-based management option to help countries develop and implement effective strategies and policies to minimize and contain AMR-related risks along the food chain. Codex has developed 3 core texts on foodborne AMR to provide a framework for addressing AMR along the food chain, and has conveniently compiled these 3 texts in a compendium that includes the Code of Practice to minimize and contain AMR, the Guidelines for Risk Analysis of Foodborne AMR, and the Guidelines for Integrated Monitoring and Surveillance of Foodborne AMR. There are also specific standards that can also help minimize and contain AMR indirectly and support the implementation of Codex texts. Today, we are going to be focusing on how to practically implement the guidelines on integrated monitoring and surveillance of foodborne AMR. The main aim of these guidelines is to assist governments in the establishment of integrated monitoring and surveillance programs. And they outline key components and considerations to offer different flexible options for monitoring and surveillance with a specific focus on foodborne AMR along the food chain, but also in the food production environment. They focus on foodborne pathogens of public health relevance, such as Salmonella and Campylobacter, and indicator bacteria, such as E. coli, Enterococcus. And they also focus on, on how to design, how to coordinate, and how to approach this in a systematic manner for antimicrobial resistance and use data collection from various sources, and to help also to compare data, to facilitate data analysis and the multisectoral data integration across the different sectors. As we know, there is a need for integrated surveillance of antimicrobial resistance. We need to have a One Health approach. We need to generate evidence across the different sectors to have interventions that comprehensively address antimicrobial resistance. So for this, FAO is working closely with the quadripartite organizations, with the World Health Organization, the World Organization for Animal Health, but also with the United Nations Programme for the Environment, UNEP. And we are working on a number of integrated surveillance initiatives. And one of the most important is the Global Integrated System for Surveillance of AMR and AMU, the GISA system. The GISA system is not yet launched, but is planned to be launched next year. And through the GISA system, what we are going to have is a repository of information coming from the different agencies on the data that is under the remit. In the case of WHO, they collect on an annual basis, and since 2015, data on antimicrobial resistance and antimicrobial use in humans through the GLASS system. In the case of the World Organization for Animal Health, they collect antimicrobial use in terrestrial and aquatic animals at the national level, and they've been also doing this for a number of years, since 2015. And in the case of FAO, we have just started this year with the collection of antimicrobial resistance in animals and food, and we will expand in the future with the collection of antimicrobial use in plant production and protection under the INFARM system. So the information coming from these 3 different systems, GLASS, Animuse, and INFARM, will be shared on an annual basis on the GISA platform to start forming a global system for integrated surveillance. As you can see also here in this slide, we are trying to synergize between the agencies. There's no overlap in the different data streams, in the different data collection mandates that we have coordinated between the different agencies. With the purpose to fulfill FAO's mandate and also to cover the gap for global integrated surveillance and to support the global efforts with the quadripartite agencies, we have developed the INFAM system. The objectives of INFAM can be summarized here. And INFAM is a global information system consisting of an IT platform and related FAO activities that assist countries in collecting, collating, analyzing, visualizing, and effectively utilizing their AMR monitoring and surveillance data, primarily coming from livestock, fisheries, and aquaculture, along their associated food products. The INFAM system is essentially designed to host and present AMR data through phenotypic antimicrobial susceptibility testing, and is focusing on priority bacterial species of public health significance, including zoonotic bacteria and foodborne pathogens, and commensal indicator bacteria from animals and food sources. And also is focusing on bacterial pathogens causing impacts in animal health and productivity. This is completely aligned with the guidelines on integrated monitoring and surveillance of foodborne AMR, but it's also aligned with the WOHA standard, the codes and manuals for doing surveillance in animals. This is the visual identity of the INFAM system. As you can see in the left side, you have with the shapes with bacilli and cocci, you have the data generation on the laboratories. In the middle side, you have the surveillance and the transformation of data on antimicrobial resistance in information that can be disseminated at different levels of aggregation. That is depicted on the right side. As you can see, this is covering the whole cycle from data generation to data analysis and data dissemination. In the INFAM system, we can talk about very simply about the architecture. On the data generation side, we are accepting data from systematic monitoring and surveillance systems, but we are also accepting pilot monitoring and surveillance activities. And this is because we understand that there are different levels of development and implementation of national surveillance programs. From the inception, INFAM also accepts officially validated data from other sources, but these are the main two sources, and the data is classified accordingly as systematic or pilot activities at national or local level. Then we are also going to be collecting in the platform data that is contextualizing the information that we receive on antimicrobial resistance, such as assessment reports from assessment tools that we use in FAO, like the Atlas tool, but there might be also surveillance plans, surveillance protocols, and different other materials that countries might be sharing in a repository of information for contextualizing the information. The core objective, in the end, is to support countries in the collection, analysis, visualization, and interpretation of the data. And for these, countries have access to a restricted private interface with interactive dashboards for visualization of their data. And also, to support the global efforts on an annual basis, we will be migrating the data from countries that accept to publish their data. We will migrate this to the global interface, to a global public interface, to provide AMR prevalence and trends at the global level. The end goal of the INFAM system is to assist countries in the development and strengthening of operational national surveillance systems that can efficiently contribute to generate reliable and timely AMR evidence in animals and food at national, regional, and global levels. Specific objectives to achieve this overarching goal are to generate high-quality AMR data, also to enhance the capacities to meet global harmonized standards from WOHA, but also from Codex Alimentarius, also provide an analysis and dissemination of the information to different stakeholders on AMR prevalence and trends. We also want, through the INFAM platform, to detect the emergence of new antimicrobial resistance traits, and of course, all this also to inform targets for the design and implementation and monitoring of the effectiveness of evidence-based interventions against AMR in agri-food systems. Through all this information, we will also be able to estimate the extent burden of antimicrobial resistance in animals and food sectors. And of course, in the end of the day, what we want is to facilitate the integration of AMR surveillance information into risk analysis, decision-making, and monitoring and evaluation processes to use all the data and utilize all this data and information that we are generating through the surveillance systems. In 2024, we have worked in the publication of several guidance materials. We have updated the website, and we have also published the manual for implementation of the INFAM system. We have also opened the first annual call for members for all countries to participate in the INFAM system through the submission of antimicrobial resistance data and also through the submission of a surveillance questionnaire that gathers and contextualizes the level of implementation of surveillance activities at the country level. So a communication was sent from FAO through official channels to the FAO representatives and also to the FAO liaison offices to contact the national authorities, the key personnel responsible for AMR surveillance across the food chain. These are responsible officers at the national level for antimicrobial resistance surveillance in livestock, fisheries and aquaculture, and also their associated food products. Through this official call, we have received nomination of INFAM focal points from countries that have already started to submit antimicrobial resistance data and information. And after the close of the call, that we expect to close the open call in October 31st, we expect to consolidate all the data, consolidate all the information, and see the feasibility for producing a global report on antimicrobial resistance, a baseline global report of antimicrobial resistance at the global level. In this request that we have sent to national authorities to nominate INFAM focal points, of course, we have also highlighted the manual, highlighted all the requirements to participate, but here I would like to summarize the 3 key requirements for countries to participate. And the first requirement is for national authorities to sit down and identify the AMR surveillance components that they might already have in their country. When we talk about AMR surveillance component, we talk mainly about peripheral laboratories that are responsible for producing a volume of isolates for surveillance, for national surveillance. We are also talking about national reference laboratories responsible for supporting the peripheral laboratory network on antimicrobial acceptability testing, standards, quality, etc. But we are also talking about a national coordinating center or a national coordinating structure that is responsible for programming activities at the national level on surveillance, that is responsible also for the analysis and dissemination of AMR results. So what we are asking countries is to identify these components and to answer to a questionnaire that is online, is inside the INFAM IT platform, and this questionnaire on different components of the surveillance system is focusing on specific surveillance programs, and we are going to talk about the different surveillance programs later, but also on the integration of these different programs as a whole at the national level. The second requirement, of course, is to identify the national INFAM focal points and start reporting the status of AMR surveillance in agri-food systems through the surveillance questionnaire, but also to start reporting antimicrobial resistance data for the different surveillance programs according to the INFAM technical specifications. And the third requirement is to countries to commit to gradually establish national AMR surveillance in agri-food systems. And for this requirement, we also have tools in FAO that support countries in the progressive advancements of the capacities of the countries to strengthen the national surveillance systems. For this, we have the assessment tool for laboratories and AMR surveillance systems, the Atlas tool, for which we are also working on the digitalization and to connect this information from the assessments that can also be used as a proxy for the quality of the data that we are receiving in the INFAM system. The INFAM system and its IT platform operate under a framework to accommodate the varying levels of development and implementation of activities across countries, and also to gather antimicrobial resistance data from a comprehensive range of microorganisms and associated specimens covering all the surveillance programs in animals and food. The INFAM framework is aiming at supporting and harmonizing the process of obtaining information at the national level and also collating AMR data in animals and food in specific and individual AMR data files. AMR data submitted to the INFAM should be collated and gathered in different AMR data files based on the reporting cycles. Here, all isolates from samples collected within the same year should be in the same AMR data file. Then we also ask countries to tell us the statistical representativeness and also the scale at which surveillance activities are implemented. All AMR data files should be characterized to indicate if the isolates are coming from pilot activities, representative or not of the national situation, or from systematic and routine surveillance programs that are representative of the national situation. Then finally, isolates should also be classified in different data files according to the surveillance program they represent. And for this, we have defined 5 surveillance programs. The first 2 surveillance programs are the diseased and aquatic terrestrial animals, and these are having primarily an animal health purpose to inform clinical decisions and antimicrobial resistance, antimicrobial stewardship. In this case, what we are talking about is isolates of bacterial pathogens in animals that are coming through passive surveillance of specimens received from diagnostic laboratories. The other 3 surveillance programs are also in here, which are healthy terrestrial and aquatic animals, and also food at processing or point of sale. These surveillance programs are also having a primarily focus on public health. What we are talking about here is about active surveillance, collecting mainly fecal samples in animals and meat samples from carcasses or from food products to understand the transmission of foodborne antimicrobial resistance pathogens, mainly Salmonella and Campylobacter, and commensal bacteria, Escherichia coli and Enterococcus, across the food chain. In this way, what we do is to ask countries to compile different antimicrobial resistance surveillance files according to the reporting cycle, the scale of activities, and also according to the surveillance programs. And these individual AMR data files are going to be sent to the INFAM data platform for digesting the information and generating automatic data visualizations. As part of the Open Call for Data in 2024, we have also been trying to expand the team of support from FAO in the regional decentralized offices, but also we've been creating communities of INFAM focal points at the regional level. So we started, of course, the work from the global perspective, from the FAO team in headquarters. Here we have the global team, also the IT developers and all the team in the agroinformatics and digitalization division in FAO headquarters. And what we did is 3 regional training sessions. The first one was conducted in Latin America. Then we had a session in Sub-Saharan Africa and also in Asia and the Pacific. In total, 167 participants from 46 countries were participating. And in these participants, mainly we had the national INFAM focal points, but also we had the FAO personnel, that are the people who are also in the pictures in the map, and colleagues also from the FAO reference centers on AMR. So through this way, what we have done is to expand and to create community for regional and global support for the generation of these INFAM data files and for the submission of information into the IT platform for this first open call in 2024. During the INFAM regional trainings, we had the scope of going through the whole journey of the data. So as we know, the different critical stages of antimicrobial resistance surveillance start with the planning of activities, planning of the surveillance plan, and putting all the elements together on how to do the sampling. So then we go for sampling at the different sites, surveillance sites. We collect the samples, then we submit the samples to the laboratory for isolation, characterization of the bacteria. Then this information needs to go into laboratory information management systems, into data management systems that allow to submit this data to the national authorities for further analysis, interpretation, but also for dissemination of this data and this information to the different stakeholders. And the INFAM trainings were focusing mainly on these last 4 elements, on the submission, on the data management of antimicrobial resistant data on antimicrobial susceptibility testing results from the laboratory through data management systems. In this case, we were having practical sessions on HUNET and also how to do manual data management and preparation of INFAM data files. Then we were also working on the submission of these INFAM data files into the IT platform. Then we were looking together at the different visualizations, relative absolute frequencies, histograms and trends that are produced through the INFAM IT platform. And then in the last day, we were having a session on how to use this information, how to use all these different prevalence and trends that are coming out from the INFAM data platform for disseminating the results to the different stakeholders and also to inform decisions for policy and for interventions. So I would also like to give some notes on what is the way forward after this year of opening the call for data and also for this year of training to INFAM focal points. So during the years 2022 and 2023, what we were doing is to develop and validate the IT solution. So we created the beta version, we had a pilot, and then what we did is also to build interoperability with data management systems and to develop the manual for implementation. And this took us to 2024. This is the year in which we are doing the early implementation of INFAM. In this year, what we have been focusing all the efforts is on having this first annual open call for data, on the publication also of guidance materials, the manual for implementation of INFAM. We've been also doing trainings in data management as part of the regional trainings. And we are also working on additional IT resources. We are also working on interoperability of INFAM with other tools. In the year 2025, so in the year 2025, if there is a possibility to have a global report, if it's feasible, if countries are participating at the public level and countries want to share this data at the global level, we will publish the first global report with baseline data on antimicrobial resistance. Otherwise, we will need to wait a little bit more for a second open call. In this year 2025, we of course plan to have a second annual open call for data. The data on antimicrobial resistance will be produced on an annual basis, as for the other platforms with the quadripartite, as for GLASS and also for Animius. And through this annual open call for data, we will also work on the integration of the data into the GISA platform, into the Global Integrated System for Antimicrobial Use and Antimicrobial Resistance. Of course, we will integrate this data with GISA, but we will integrate with other data platforms also inside FAO. In FAO, we have also the Hand in Hand initiative. We have the agroinformatics platform that also has information on transboundary animal diseases, also on other health aspects and other aspects on data that will be very useful to connect with the data coming from the INFAM system. In 2026, we will consolidate all the lessons learned over the last years. We will also continue with the annual open calls and reporting of the information, but we will consolidate all this knowledge. Also, maybe we need to do a global consultation with the stakeholders to understand and to see what is the future of the platform beyond the early implementation. And we also want to include additional surveillance activities and additional surveillance data that is also under the remit of FAO. We would like to put more attention also on antimicrobial use in plants and crops. And of course, we would also like to work on the collation and the collection of data coming from whole genome sequencing, from next generation sequencing techniques into the INFAM IT platform, because we understand this is also the future, and this is also the trend that is also at the global level. A lot of antimicrobial resistance data is already being generated through these new techniques. And with the way forward, I would like to finish thanking our donors, the Ministry of Food and Drug Safety of the Republic of Korea, also the Fleming Fund from the United Kingdom. And we would like to thank you for all the support that we've been receiving through these projects. And I wish you a very good meeting and a very good conference on Foodborne AMR. Thank you very much.
Now we got some information on the INFAM system. Now I will introduce the last presenter. She is Dr. Myeong-shin Choi. She works with the FAO as a food standard officer, and she is working as the food standard coordinator as well. So we don't have much time. So yes.
My name is Choi Myeong-shin, Food Standard Officer in FAO. First of all, I would like to say thanks to the Ministry of Food and Drug Safety for organizing this important meeting. This meeting provides opportunity to share our information and experiences. I feel the urgency in two ways. AMR is here. We have to work together urgently. At the same time, I have a limit of time, so I have to explain quickly. What does that mean, ACT? ACT stands for Action to Support Implementation of Codex AMR Text Project. It is the first project in Codex to support countries directly in implementing Codex standards in FAO, which is dedicated only to foodborne AMR. This project started in 2021 by the support from the Ministry of Food and Drug Safety with a budget of $10 million for 5 years. We have chosen 6 low middle income countries, 4 countries in Asia, which are Cambodia, Mongolia, Nepal, Pakistan, and 2 countries in Latin America, Bolivia and Colombia. I have developed a video to introduce the ACT project and how ACT project works. 저 비디오 틀어주세요. 비디오.
Globally, an estimated 5 million people die every year from an infection associated with antimicrobial resistance, or AMR. This has been called the silent pandemic. The emergence and spread of what are often called superbugs is accelerated by human activity, mainly through the misuse and overuse of antimicrobials in humans, animals, and plants. However, the spread of AMR can be contained. And since 2021, a project implemented by the Food and Agriculture Organization of the United Nations, or FAO, has been working to tackle the threat of foodborne AMR. The action to support the implementation of Codex AMR texts, or the ACT project, is a 5-year initiative working in 6 countries, 4 in Asia, Cambodia, Mongolia, Nepal, and Pakistan, and 2 in South America, Colombia, and the plurinational state of Bolivia. The Codex Alimentarius, or Food Code, is a set of standards, guidelines, and codes of practice aimed at protecting consumer health and facilitating fair practices in the food trade. The ACT project specifically aims at the successful implementation of 3 Codex AMR texts: the Guidelines on Integrated Monitoring and Surveillance of Foodborne Antimicrobial Resistance, the Guidelines for Risk Analysis of Foodborne Antimicrobial Resistance, and the Code of Practice to Minimize and Contain Foodborne Antimicrobial Resistance. Funding for the project has been provided by the Ministry of Drug and Food Safety of the Republic of Korea.
항생제 내성은 국가적인 보건 위협으로 한 국가가 해결하기 어렵습니다. 따라서 모든 나라가 동참해야 합니다. 대한민국은 식품 생산 체계에 있어서 항생제 내성 저감화를 통하여 국제적인 항생제 내성 저감화에 기여하고 이를 통해서 안전한 식품 생산에 기여하고자 합니다. 이것이 대한민국이 FAO를 통해서 이 사업을 지원하는 이유입니다.
The ACT project sets out a 4-pillar pathway to implementation that supports each project country to improve the governance, surveillance, and awareness of foodborne AMR, as well as to improve the application of relevant good practice.
And it's the first time that actually a project does this, takes a document, goes to the country and translates it into actions. For example, doing activities like capacity building of laboratories, training of different workers along the food chain,
or, for example, doing legal work.
Legal work under ACT promotes improved governance, and the project has worked in collaboration with FAO experts to develop the ACT tool, which helps countries to assess their regulatory framework regarding foodborne AMR.
In this first phase of implementation of the ACT tool, we have primarily focused on what's written in the law to check how well prepared countries are to incorporate international recommendations into their legislation.
In Bolivia, the government has established CCRAM, a multi-sectoral committee for the containment of AMR. CCRAM consists of public and private sector actors who discuss how to address the gaps in legislation identified through the ACT tool. Within the committee, there's a growing sector-wide acknowledgement of the project's relevance and of the importance of Codex texts.
El uso de las directrices del Códex son fundamentales para nuestro país. De manera inicial se ha expresado el interés desde el sector bovino de poder implementar en su totalidad las directrices del Códex.
The fact that the bovine industry recognises the threat of foodborne AMR and the benefits of implementing the Codex guidelines is a signal that the project is succeeding in its goals and is well supported. This has significant economic potential as Bolivia's bovine sector is experiencing positive growth with expanding export markets. The improved surveillance pillar of the project is closely linked with governance. Continual surveillance provides the government with the required data for it to identify patterns of antimicrobial resistance and the pathogens, antimicrobials, and food sources involved. In Bolivia, this information allows CCRAM to prioritize the most pressing areas of concern. The ACT project is training participants at different steps of the food chain, including these laboratory technicians who work for the National Service of Agricultural Health and Food Safety, SENASAG.
El impacto en Bolivia que va a dejar el proyecto es muy grande. Principalmente vamos a tener un laboratorio preparado con todos los procedimientos y los controles internos y las normas internacionales que se pueden tener para el ensayo metodológico. Y en este caso, así el laboratorio va a poder emitir resultados que sean confiables y auditables, ¿no? Adicional a eso, como laboratorio podemos ser un centro que pueda transmitir toda la capacitación que ha recibido de la FAO a los otros laboratorios que trabajen el tema de RAN, ¿no?
En los años que vienen empecemos a tener información seria, información de calidad para la toma de decisiones y que sabemos que esto no solo beneficia a la parte de sanidad animal, sino que es una parte de la vigilancia integral de la RAM.
The ACT project aims to build on the good practices that can already be seen in Bolivia. Here at this ranch, every effort is taken to reduce disease through good hygiene practices and thereby reduce the need to use antimicrobials altogether.
La prevención y la detección a tiempo son claves para no tener que llegar a usar antibióticos. Y luego de esto, cuando se compromete la sanidad de un animal, la vida de un animal, debo usar los antibióticos, pero también debo ser consciente del periodo de retiro antes de colocar ya sea la leche o la carne al consumo humano.
Another example of good practice can be found at this slaughterhouse near Santa Cruz, where work is divided into 3 distinct areas in order to avoid cross-contamination.
Tenemos nuestras áreas delimitadas, como ser área limpia, área semilimpia y área gris. Esto tanto para la planta de faenamiento como también para nuestros vestidores, nuestros baños, nuestras áreas de recreación y comedores. Con esto aseguramos que no haya ningún tipo de contaminación cruzada. Todos nuestros proveedores de pollo vivo, que es nuestra materia prima, son habilitados y todos estos cuentan con certificados sanitarios y con todas las normas que nos exige nuestro ente regulador.
Biosecurity is taken very seriously at this poultry farm on the outskirts of Santa Cruz.
Nosotros, por un tema de diseño de la granja,
apostamos por tener una mayor bioseguridad y un mayor control con el personal. Por tanto, tenemos desinfecciones al ingreso, desinfecciones al ingresar en cada galpón. Podés evitar muchos problemas que te puedan dar por un simple personal que no ingresó haciendo la desinfección correcta, ¿no?
Improved governance, surveillance and good practice must be accompanied by raising awareness about food production and consumption and the need to use antimicrobials responsibly and prudently.
El desafío grande ahora está, digamos, concientizar a aquellos pequeños productores donde todavía no van de la mano con un veterinario, ¿no? O aquellas veterinarias que todavía no hemos podido, digamos, controlar para que ellos puedan vender el producto directo a los productores, ¿no? Sin una receta médica.
This farmer is aware of the need to minimize antimicrobial use and believes greater awareness will influence other producers.
Tomaría un tiempo en convencerlo, pero creo que es posible.
Everyone has a role to play in ensuring food safety and reducing the misuse of antimicrobials. This includes all stakeholders in the food chain, from the farmer and veterinarian to the processor, retailer, and the consumer. Change is challenging, but through continued education and awareness, we can create a more responsible and sustainable food system.
Sabemos que cada uno de los países tiene sus propias particularidades, sus propias necesidades y también existen muchas oportunidades de mejora que se comparten entre todos esos países. Por lo tanto, hay información y hay experiencia desde el proyecto ACT, ¿verdad?, en Bolivia y en Colombia, que pueden servir de guía para estos otros países a nivel regional.
The ACT project will continue until 2026. And it's expected that implementation of the Codex AMR texts will lead to better management of foodborne AMR in the 6 supported countries. And the results will then be used to plan effective interventions to promote the adoption of Codex standards elsewhere.
이제 멈추어 주세요. Today I have shared only story of Bolivia, but I have more stories to tell. I have to conclude. I still remember when we started activities in Bolivia, they told us we don't have any laboratories to test AMR, and we don't have any capacities. But now they do the AMR test, and they have developed the CCRAM to discuss AMR issues with the stakeholders, and they are developing surveillance systems. ACT project makes a difference. So I want to invite you to support other countries as well. There is no border in terms of AMR. We have to work together. Thank you very much.
최 박사님 많은 시간 못 드렸.
Thank you very much. I'm sorry that I could not give you much time. So we did have some time distribution issues. Sorry about that. So because of time, I don't think we can take questions. So if you have any questions, I think you can contact Dr. Che directly for your questions. And now with this, we will conclude all of the sessions of today's conference. Thank you for your participation.
During session 4, we learned more about global efforts in various ways to reduce AMR. Particularly, we also have seen a video that our ministry is supporting. I would like to give thanks to Professor Chong-Chun Choi for chairing the session, as well as the 4 speakers for their insightful presentation. Thank you so much. There was one request from the floor. Thank you so much, everyone, for your active participation and attentive participation, as well as to our speakers and session chairs for guiding us through the presentations. I would like to give thanks on behalf of the conference. Please note that the presentation videos and materials will be available on the official website of our conference. I would like to have your cooperation in giving us valuable feedback. There is a QR code on the screen as well as on the booklet. Please fill out the survey using the QR code for our improvements of the conference. The QR code will also be shown for online audience. With that, we conclude the programs of the 4th Global Conference on Foodborne Antimicrobial Resistance. I hope that this conference has contributed to combating foodborne AMR going forward. Thank you so much.